There, you're in the lab with your mate JJ. Today is unboxing day. We're going to be doing a quick unboxing today, or maybe a not so quick unboxing. I guess we'll see. The unboxing itself will be quick, but we're also going to have a look at some of the manual and specs and stuff, and that might take a little while. So if you're just in it for the unboxing, we'll do that straight away, and then after that we'll follow up with some of the additional material. My silly job title for today is Digital Dancer. Today I'm the Digital Dancer. And the digital technology that I'll be dancing with is this guy. This is the Sharp EL-506TS. The one that I've got is white. It also comes in black, but I got the white one. I think they sell the white one on the Australian market and they sell the black one on the US market, as near as I can tell. Anyway, I bought this on the Australian market over at eBay, in fact, and I'll show you the details of that later on. So the first thing we'll do is we'll jump over the booth, we'll jump over the bench here, and we'll take this guy out of its packaging. There's not much to it; it's just going to pop out. We'll have a look at the packaging. We'll take it out. We'll have a look at it. Then I'll bring you over to the computer. I'll show you where we bought it. We'll go through the specs. Then we'll have a look at the manual, and maybe we'll come back after that and demo some calculations with it or something like that. I guess we'll see. So let's jump over to the bench and take this guy out of its box. All right, so here we are on the bench, and this is our calculator. Of course, it's a scientific calculator. It is not a graphing calculator, and it is not a programmable calculator. It's a boring Yumcha old thing. I bought it because it's the latest in the lineup of the Sharp EL-506, and this is my Sharp EL-546L, which I got back in the early 90s. I think around 1993 I got this. I've had it ever since. It's done me high school and university. I've been using this particular calculator my whole life, and it has served me well, which is why I got this. I got this purely for nostalgic reasons. I just wanted to check out what the latest word on this model actually is. So I just got it out of curiosity and nostalgia, because I have other calculators which are technically much better, particularly this, which is the Casio FX991CW Class Whiz. This thing's pretty nifty, and it's more capable than this, and also this one has two line display. The Class Whiz, the CW, has 4-line display, and it can do algebraic stuff. Keeps like root 2 and root 3 and all this sort of thing algebraically, rather than showing it decimal approximations. So this is pretty nifty. If you're interested in it, I've done a video on this as well. If you want to see a demo of this, let me know and I'll do that. I don't think we're going to be doing any demos today. We could do a demo of this in the future. If you want me to put this through its paces, let me know. Or maybe we'll do that at the end of this video. I guess we'll see how we're going for time. So yes, this is the original Sharp EL-500 series calculator that I had, and this one is the new model in the same series. So what does it have to say about itself? On the front, it says it's got 470 functions. It can do matrix calculations. It's got a home key and twin power. Twin power, of course, means it's battery and solar, and you can see the solar up the top there. It's telling us to be careful. It's got a battery in it. Fair enough. This is a scientific calculator. Of course, we knew that. So here is the actual size of the display. So it's got a top line for the calculation and a bottom line for the results, and it uses the old 7-segment liquid crystal display down there. So that's a pretty simple old school display, isn't it? A lot of the stuff these days will use like a actual grid. So sorry, you know, like a pixelated screen. This is not that. This is segmented display. So it says that it's got matrix calculations, so you can enter matrix A and matrix B and then subtract them and multiply them and this sort of thing. Okay, and multi-line playback. Okay, so you can edit across lines by the looks of it, and it's got substitution algebra. I'm not exactly sure what that means. I'm not sure, and there's a big sticker someone put on here telling us that the EL-506TS BWH is the same as the A version of the same model. Okay. Sharp.net.au manuals and software. We'll check that out in a minute. And there's some specifications over here, but they're cut off a little bit by this sticker. So we might have a look at the specifications together over on the computer in just a minute. So that's everything to show you about the packaging itself. So let's pop this thing off. Looks like it's going to be, oh no, it's going to be tricky. All right, I'll do it in fast forward. Let's do this quickly. All right, so I managed to cut it out of its container. I wasn't expecting the manual, but there it is. It's in the back there. We'll have a look at that together now. So I will keep this in my scrapbook. In fact, why won't we do that together just quickly now? I'll just throw you over here, and my scrapbook is down here, and I'll be putting this in the back here. All right. I do like keeping bits and pieces because I'm a bit of a nerd, so I keep the packaging and scrapbook things. All right, so let's jump back over to the bench, and here we are with the manual and such. So I'm not sure. This is Italian. Yeah, okay. Yep, it's all Italian, Italian, Italian. I don't know if we get the same information in this one. What have we got here? Yes, right. Okay, so these are different. Okay. Wow. Okay, there's a lot to see here. Okay. And this is Italian, and also it's got some extra stuff on it. Underneath the Italian is what have we got here? We've got calculation examples, and it says Italian, but it seems to be in English as well. Okay, there's a bunch of examples. I think we'll run through those, won't we? We'll do all of these examples. Why not? Why wouldn't we do that? Okay, so there's 22. Oh, no, that goes on. Okay, wow. All right, so you can't see, but it goes all the way down here. 20, 29, 30. Okay. And then it says for EU only, manufactured by Sharp Corporation. And they've got an address in Japan, imported into Europe by Moravia Consulting, okay, in the Czech Republic. For Australia and New Zealand only, for warranty information, please sharp.net.au. Okay, this product contains button batteries. Keep batteries out of reach of children. Okay, information on disposal of equipment and its batteries. Physical constants and metrics conversions are shown. So those are down here. We'll have a look at those later on. And what about this? This is just a manual in Italian. Okay. So the whole back thing here is in Italian. Okay. So I don't know about you, but I don't speak Italian. So we've got this side, which is the calculation examples. So we'll definitely work through that. That's quite interesting. So I'll just put that over here. And then this is the manual in English, front and back. Okay. And let's just see if it's comparable to the Italian. So this says introduction. Okay, operation notes. It says nota operative. That's the same thing. Display, it's the same. I'm just trying to show you here that the English and the Italian are commensurate. So they've got an intro, operation notes, display, before using the calculator. So prima di usare la calculator. Yeah, I don't speak Italian, but that looks very much the same. So we've got an English manual and we've got an Italian manual, and then we've got calculation examples in Italian and English. Okay, so what are we going to do? I think we're going to read this, and then we're going to do the examples. Why not? I'd like to take it for a bit of a spin. So this is a good excuse for that. And then we'll jump over to the computer, and we'll have a look at what electronic information we can find. And then I think we'll call it done. That's everything, isn't it? That'll be quite a long video. So for the people who were just in it for the unboxing, we have taken this guy out of the box. I'll be putting you in close zoom mode in a second. That's probably too close. Can we do? Yeah, is that good enough? I don't know. What about that? That looks fairly good to me. So I guess I should show you. How does it slip in here? I'm not sure. Does it slide out, slide in? Oh, there we go. All right. Okay, cool. Well, that's actually a bit different to how the old one worked. This one obviously comes in two parts. We've got the. I should put you out to the main screen. Main screen, turn on. Okay, so we've got the back cover here. This is a little bit of dust or something on it. What is that? I don't know what that's from. That might have been cutting plastic when I cut the plastic off. Okay, it's got screws for the battery holder at the back. Screws here as well to take the whole thing apart. There's some sort of a serial number on this thing. I don't know what that is. There it is. It's turned on. Let me show you the old Sharp 500 series calculator I had this thing where you could flip the calculator around like that, and the case was permanently connected to the calculator itself. I always thought that was pretty natty, so I'm not sure why they got rid of that with the latest version, but they have. So now the calculator slides in like that, and then out into two pieces, and then you can house it in its container as well, just like that, which is a small matter. That's not a big deal. Let's have a look at this. So there's a little note in the back of the calculator. Let me zoom you in on that again. Can you see that a bit better? So it says setup menu, setup. Okay, there's a setup menu. Where is that? Here it is. Okay. 0 degree angle setup. So you can choose degrees, radians, and gradients. And then option 2 is display, enter display format. So that's the second option, labeled as 1. The first one's 0, the second one's 1. You can choose fixed, scientific, engineering, or norm 1 and norm 2. And then you can choose tab. And the mode selection for tab is normal mode, statistics mode, equation mode, complex number mode, matrix mode, and list mode. Okay. And again, this is the EL-506TS. Okay, very good. So let's have a look together at the manual. I'll throw you back over to the large screen, and we'll just put this aside for the minute. It'll be second function off. There we go. I'll just turn him off and put him in the corner. And let's read the manual. This might take a little while. You won't be able to read it very well. I don't know if there's a English version of this, sorry, a PDF version of this manual. This is called the operation manual. Let me just go check. All right, so I had a look. This manual is pretty short. It's only this page on the front and then again on the back. It's pretty small print, but it's only 2 pages. There is a manual available for download. It's 44 pages. So I think we'll do all of it. We'll read this one first. And then what will we do after that? We'll read this one first. Then we'll do these examples. Then we'll jump over the computer and look at the electronic information, which includes the specifications and the 44-page PDF manual. And that will well and truly do it. So this is going to be a pretty long video, I think. So the first thing we're going to do is this, then this, and then we'll go over to the computer. So also, let me just scan this stuff. Let me scan it and I'll be back in a sec. All right, well, I scanned these documents and very importantly, got myself a fresh coffee. So, one of them's still in the scanner. I'll just go and grab that. What have we got here? Okay, this is the one we're going to do first, which is the operation manual. And then once we've had a look at that, we'll do this one, which is the calculation examples. So we'll do calculations examples second. I'm just going to read this out. You won't be able to see it because the resolution's probably not good enough for you. If you'll be able to find scans of these on the wiki. If you go looking, there'll be a link in the show notes. I'm just going to read it. So this is the English Sharp Scientific Calculator Operation Manual for the model EL-506TS. It's printed in China. Introduction. About the calculation examples, including some formulas and tables, refer to the reverse side of the Italian manual. Okay, well, we did that. We'll be looking at those later. I've scanned them. I didn't scan the Italian manual, by the way. I don't have any use for that myself. Refer to the number on the right of each title in the manual. Refer to the number on the right of each title in the manual for use. That's one of those sentences I'm going to read again and again and again until I understand what it told me. Refer to the number on the right of each title. Oh, I see. Here. Okay, good. So this is the number on the right of the title, and it's a reference into the example calculations, I guess. Is it? Yeah, it must be. So let's just see if that stacks. So multi-line playback function, number 1. Okay, yeah, that looks like multi-line playback to me. Up, down, down, up. Okay. And what about, let's say, fraction calculations, number 10. Yeah, that looks like fraction calculations. Okay, great. So these headings are in the operation manual, refer to sections in the calculation examples. So that's good that they're cross-referenced like that. We'll just be reading them through top to bottom, so we won't be looking up the examples as they occur. Or maybe we will. Maybe that's the best way to do it. Okay. It says there's 30. It gets up to 30. What about this guy? Gets up to 30. Okay, so everything seems to be complete. All right, we'll chop and change. We'll read the operation guide, and then when we get to a section regarding the calculation examples, we'll just pop over to it and we'll do it as we go. So we're going to be reading the operation manual and referencing the calculation examples. Very good. After reading this manual, store it in a convenient location for future reference. Well, I've certainly done that. I've scanned it and it's on the wiki, so if you need it, you know where to find it. The scans seem to be fairly high quality too. They were legible, which is good. Operational notes. Okay, do not carry the calculator around in your back pocket as it may break when you sit down. The display is made of glass and is particularly fragile. Okay, keep the calculator away from extreme heat, such as on a car dashboard or near a heater, and avoid exposing it to excessively humid or dusty environments. Since this product is not waterproof, do not use it or store it where fluids, for example water, can splash onto it. Raindrops, water spray, juice, coffee, steam, perspiration, etc. will also cause malfunction. Clean with a soft, dry cloth. Do not use solvents or a wet cloth. Avoid using a rough cloth or anything else that may cause scratches. Do not drop it or apply excessive force. Never dispose of batteries in a fire. Keep batteries out of the reach of children. This product, including accessories, may change due to upgrading without prior notice. Right. There's a notice here. Sharp strongly recommends that separate permanent written records are kept of all important data. Data may be lost or altered in virtually any electric memory product under certain circumstances. Therefore, Sharp assumes no responsibility for data lost or otherwise rendered unusable, whether as a result of improper use, repairs, defects, battery replacement, or after the specified battery life has expired, or any other cause. Sharp will not be liable nor responsible for any incidental or consequential economic or property damage caused by misuse and or malfunction of this product and its peripherals unless such liability is acknowledged by law. Okay. Press the reset switch on the front with the tip of a ballpoint pen or similar object only in the following cases. Do not use an object with a breakable or sharp tip. Note that pressing the reset switch erases all data stored in memory. When using for the first time, okay, after replacing the battery, okay, to clear all memory contents, and when an abnormal condition occurs and all keys are inoperative. If service should be required on this calculator, use only a Sharp servicing dealer, Sharp approved service facility, or Sharp repair service where available. All right, well, let's do that. So, find something to press the reset button with. Here it is. All right, so I might as well zoom you in for this one. There we are. Now the reset switch is here. So let's press it. And it turned itself off and turned itself back on again. So I think we can consider that pressed. All right, did say to do it before first use, so there we go. All right, now there's a hard case that you can slide in and out. We looked at that already. There's a display, the equation on the top line, the mantissa and exponent on the bottom line. And there's a bunch of symbols across the top. During actual use, not all symbols are displayed at the same time. Certain inactive symbols may appear visible when viewed from a far off angle. Okay. Only the symbols required for the usage under instruction are shown in the display and calculation examples. Okay. Left arrow and right arrow appears when the entire equation cannot be displayed. Press left and right to see the remaining hidden section. X, Y / R theta indicates the mode of expression of results in the complex calculation mode. Okay, that is of course rectangular form and polar form. Up and down indicates that data can be visible above, below the screen. Press up or down to scroll up or down the view. Second function appears when second function is pressed. Okay. Hype indicates that hype has been pressed and the hyperbolic functions are enabled. If second function arc hype are pressed, the symbols second function hype appear, indicating that inverse hyperbolic functions are enabled. Okay. Alpha appears when alpha, statvar, STO, or RCL is pressed. Okay. Fix/science/engineering indicates the notation used to display a value. Degrees, radians, gradient indicates angular units. Mat. Mat appears when matrix mode is selected. List. Sorry, I might as well keep you zoomed out there, huh? Yeah. List appears when list mode is selected. Stat appears when statistics mode is selected. M indicates that a value is stored in the independent memory. Question mark indicates that the calculator is waiting for a numerical value to be entered, such as during simulation calculation. Angle appears when the calculator shows an angle as the result in the complex calculation mode. I indicates an imaginary number is being displayed in the complex calculation mode. Okay. So, before using the calculator, key notation used in this manual. In this manual, key operations are described as follows. To specify e to the x, press second function e to the x. To specify ln, just press ln. And to specify f, press alpha f. Okay. Function. So second function's top left, alpha's top right, and the main function's on the key itself. Functions that are printed in orange above the key require second function to be pressed first before the key. When you specify the memory, press alpha first. Numbers or input value are not shown as keys, but as ordinary numbers. Numbers for input value are not shown as keys, but as ordinary numbers. Oh, I see, right. So when you're typing in the number, they just give you the number, not the keys to press. Fair enough. Power on and off. Press on/C to turn the calculator on and second function off to turn it off. Clearing the entry and memories. Okay. Okay, so there's the display. There's M, F1 to F4. Okay. Your A to F, X, Y, and answer. Stat var, and mat A to D, L1 to 4. All right. So if you I'm not sure what the circle or the cross indicates. Clear, retain. X for retain, 0 for clear. Okay, so you press on, it'll clear the display, but it'll retain everything else. If you press CA, it'll clear everything except for the memory F1, F4. If you change the mode selection, it'll clear everything. Okay, the reset switch. Okay, and M clear. Okay, so
Statistical data is the stat stuff. Stat var is, oh yeah, okay, mean, standard deviation, statistics variables. Yep. Matrix memories. There's 4 matrix memories: mat A, mat B, mat C, mat D. There's 4 list memories. Number 5, all variables are cleared. Number 6, this key combination functions the same as the reset switch. All right, so second function mclear 1 0 is the same as pressing the reset button. So the memory clear key, press second function memory clear to display the menu. To clear all variables, press 0 0 or 0 enter. To reset the calculator, press 1 0 or 1 enter. The reset operation will erase all data stored in memory and restore the calculator's default settings. All right, let's try that. So we've got, let me turn this guy on. Here we go. All right, so where is the power button? Here. And second function. And what was the thing? mclear. Where is mclear? Can we see it? It's a second function. I was expecting it to jump out at me. All right, I'll find it and I'll be back. Hang on. All right, I found it. It's right down the bottom here on the plus and minus button. So we press second function, mclear, and then you've got 0 and 1. So we press 0, 0. Okay. Let's try second function, mclear. And what was the other way to do it? Press 1 0 1 0. Okay, and that was the same as pressing this reset button here. Okay, let's turn him off, and we'll keep on going through our notes. Bring you back over to the big view. So, entering and correcting the equation. So we've got cursor keys. Press left or right to move the cursor. You can also return to the equation after getting an answer by pressing right or left. See the next section for using up and down keys. See setup menu for cursor in use in the setup menu. Okay, insert mode and overwrite mode in the equation display. Pressing second function insert switches between the 2 editing modes, insert mode, which is default, and overwrite mode. A triangular cursor indicates that an entry will be inserted at the cursor, while the rectangular cursor indicates to override pre-existing data as you make entries. To insert a number in the insert mode, move the cursor to the place immediately after where you wish to insert, then make a desired entry. In the overwrite mode, enter the data under the cursor will be overwritten by the number you enter. The mode set will be retained until the next reset operation. Okay, so you press second function insert to toggle between insert and overwrite. There it is there, second function insert. Okay, well, we'll probably see an example of that soon when we do our calculation examples, we'll see. All right. Deletion key. To delete a number or function, move the cursor to the number or function you wish to delete, then press delete key. If the cursor is located at the right end of the equation, the delete key will function as a backspace key. Okay. Multi-line playback function. Okay, so this is example is given in number 1. So we'll read the section, then we'll look at the example, and then we'll come back. So this section's multi-line playback function. Previous equations may be recalled in the normal mode. Equations also include calculation ending instructions such as equals, and a maximum of 142 characters can be stored in memory. When the memory is full, stored equations are deleted in the order of the oldest first. Pressing up will display the previous equation. Further pressing up will display preceding equations. After returning to the previous equation, press down to view equations in order. In addition, second function up can be used to jump to the oldest equation. The multi-line memory is cleared by the following operations. Second function CA, I think CA stands for clear all. Mode change, reset, end-based conversion, and memory clear, which is second function mclear. Okay. Priority levels in calculation. Operations are performed according to the following priority. 1. Fractions, 1 on 4, etc. 2. Angles and engineering prefixes. 3. Function preceded by their argument, such as x to the minus 1, x squared, n factorial, etc. 4. Y to the x, the xth root. 5. Implied multiplication of a memory value, 2y, etc. 6. Functions followed by their argument, sine, cos, etc. Implied multiplication of a function, 2 sine 30, etc. 8. NCR, NPR. 9. Multiplication and division. 10. Addition and subtraction. 11 and 12 or x nor. 13 equals m plus, m minus, and store m. And then degrees, radians, gradients, data, CD, convert to polar form, convert to rectangular form, and other calculation ending instructions. If parentheses are used, parenthesized calculations have precedence over any other calculations. Okay. So before we go on to the initial setup, let's have a look at multi-line playback in the calculation examples. So there's the example they give us. Shall we zoom in? I suppose we shall. There we go. So we're looking at this part here, number 1, and we're going to be doing that on the calculator here. So let me see if you can get that all in the picture. Okay, so clear all, where is that? On, okay, and then 3, open brackets, 5 plus 2, close brackets, equals, okay, 3 times 7, 21, that's right, okay, and then okay, now we do 3 times 5 plus 2, 3 times 5 plus 2. Oh, I pressed it wrong. 3 times 5 plus 2. Okay, so that's 3 times 5 is 15, plus 2 is 17. That's correct. And it wants us to do 3 times 5 plus 3 times 2. And it says we get 21, and we do. Now, if we press second function up, where is up? Up, up, up. Why am I not seeing it? Oh, this must be up, F1. Is that right? Yeah, these are the arrow keys. Okay. So second function up. Okay. Okay. All right. So, and then if I press equals, okay. So we can press second function up, and that takes us to the first equation. And we can't go any higher than that. And then we can press down to come to the next one, and down again, and then down again. And then we actually end up with a duplicate at the very bottom because I did that. All right. So there we go. Now we know how to edit equations in the equation editor. Very good. So now on we go with the initial setup. Mode selection. Okay, so there's normal mode, statistics mode, equation mode, complex number mode, matrix mode, and list mode. Okay, so there's a mode key. Let's find that. I suppose I might as well try to remember to zoom you in when I'm using the thing. So where is our mode key? There it is. All right, so let's press on to clear everything, and then mode, and it looks like, yep, okay. So you can scroll through. Cool. Well, I guess we'll learn about the other modes later on. The home key. So press home to return to normal mode from other modes. Okay. Note, equations and values currently being entered will disappear in the same way as when the mode is changed. Okay, so the home button will get you back into normal mode. Then there's an example here of the setup menu. So I suppose we might as well just, let's just try, because it doesn't look like it's going to show us, but if we put it in mode 1 for statistics mode, that wasn't what I was expecting. Oh, I see. So it looks like, oh wow, there's a bunch of additional modes. Okay. Okay, so we're in stat 0, and we press home. She'll put us back in normal mode. Yeah, okay, cool. All right. So setup menu. Press setup to display the setup menu. A menu item can be selected by moving the flashing cursor, by using left and right, and then pressing enter or equals. It's the same thing. Okay. Or pressing the number key corresponding to the menu item number. If up or down is displayed on the screen, press up or down to view the previous/next menu screen. Pressing on/C to exit, press on or /C to exit the setup menu. Okay. Determination of the angular unit. The following three angular units, degrees, radians, and gradients, can be specified. Okay, so for degrees, you press setup 0, 0. For radians, you press setup 0, 1. And for gradients, you press setup 0, 2. Selecting the display notation and decimal places. 4 display notation systems are used to display calculation results: floating point, fixed decimal point, scientific notation, and engineering notation. When the fixed, sci, or engineering symbol is displayed, the number of decimal places, tab, can be set to any value between 0 to 9. Displayed values will be reduced to the corresponding number of digits. Setting the floating point numbers system in scientific notation. 2 settings are used to display a floating point number: norm 1, which is the default setting, and norm 2. A number is automatically displayed in scientific notation outside a preset range. Okay. So, okay. So norm 1 uses a lot of digits, and norm 2 uses 2 digits, 2 decimal points, or 3 significant digits. Okay. So let's do the example number 2. I'll zoom you in here. All right, we're looking at number 2, which is here. So press on. Okay. How many zeros is that? 100,000. Oh, they've got a little a comma, apostrophe that shows the thousands place. All right. Divided by 3 equals. All right, so that's in norm 1. Okay. And then we press set up 1 0, set up 1, which is fixed point, and 0 fixed. Okay. Okay, well that didn't really change anything, did it? Okay. Or did it? Let's start again. How do we put the how do we put it back in norm 1? Set up 1 3. Okay. Set up 1 3. Norm 1 3. Okay, it's gone back to normal mode. And let's do 100,000 divided by 3. Yeah, okay. So it does say the same as fixed. Okay. So let's put it in. Let's put it in fixed and then change the tab. So set up 1 fixed, and then set up to 2. Set up 2 is the tab. Setting is 2. Okay, there we go. So we've got 2 decimal places there. The tab setting is the number of decimal places. Very good. Then we can put it in scientific mode with setup 1 1, setup 1 1. Okay, so that's 3.33 times 10 to the power of 4. And if we put it in engineering mode, setup 1 2, that's 33.33 times 10 to the 3. Okay, and then we can put it back in norm 1 with setup 1 3. Setup 1 and 3 is norm 1, as we thought. Great. So, and then the other one is 3 divided by 1,000 equals, okay, 0.03, 0.003. And if we put it in norm 2, which is set up 1 4, oh, okay, there we go. It's 3 times 10 to the minus 3. Right, and if we put it back in normal mode, then it's back to 0.003. Okay, fine. Good. So that was initial setup menu. Scientific calculations. Press mode 0 to select the normal mode. In each example, press on/C to clear the display. If the fix, sci, or eng indicator is displayed, clear the indicator by selecting norm 1 from the setup menu. Okay, good. This is arithmetic operations. Okay, we'll do that in a second. The closing parentheses just before equals or m plus may be omitted. Okay, so you don't need to explicitly close your parentheses. That's something. So we're up to number 3, which is over here. Let's see, what do we got? So on C, 45 plus 285 divided by 3 equals, and we're supposed to see 140, and we do. And then we're going to see, okay, we're going to do some bracketed expressions. So this is 18 plus 6, close bracket, divided by, open bracket, 15 minus 8. And the other bracket is not necessary, so we press equals, and we get 3.42. Very good. And then we're going to have 42 times, open bracket, 5 negative, close bracket, plus 120. Oh, I see. Oh, I see, right. So we get minus 90 if we do it that way. Can we edit that? Yeah, we can. Oh no, we don't want that one. We want, yeah, this one. Oh, I see. Okay, let's do this thing from the top. So let's say 42 times 5 negative, okay, plus 120. There we go. So you press 5 negative and it automatically puts the brackets in there for you. That's good to know. I actually put those brackets in myself, but you don't need to do that. Okay, that's good. That's good learning. And we press equals should give us minus 90, and it does. And so there was one more example here. 5, where's exponent? There it is. 3 divided by 4 exponent 3 negative equals, okay, 1,000, 1,250,000. That's correct. All right, good. So that was arithmetic operations. The next is constant calculations. In constant calculations, the addend becomes a constant. Subtraction and division are performed in the same manner. For multiplication, the multiplicand becomes a constant. In the constants calculation, constants will be displayed as k. All right, so let's have a go at that. Number 4. Okay, they've got 34 plus 57. 34 plus 57 equals, you get 91. Ah, I see. So you press equals. Okay. Okay. Let's try this again. Let's go 68 times 25 equals, and then we press 40 equals, and it'll be K times 40. Dear me, I find that very confusing. In the first case, the constant's the value on the right. In the second case, the constant's the value on the left. Okay, I'm just going to say I don't understand that. If you understand this and you want to explain it to me, please do. But I don't get it. 68 times 25 equals 40 equals. Okay, I don't get that. On we go, on we go. Let's just read that again. Constant calculations. In constant calculation, the addend becomes a constant. Subtraction and division are performed in the same manner. For multiplication, the multiplicand becomes a constant. In the constant calculation, constants will be displayed as K. Okay, so I'd have to know what the addend and the multiplicand are. And it seems like in the first one, the right-hand side is the addend, and in the second one, the multiplication is the first for the multiplicand. Strange. All right. So over we go. Functions. Refer to the calculation examples of each function. Before starting calculation, specify the angular unit. Okay. So there's going to be a whole bunch of these. There is indeed. All right. So we're looking at this, which is the examples of various functions. There's a whole bunch of them. So let's put our calculator where we can see it. All right. So this is sine, cos, tan, inverse sine, inverse cos, inverse tan, pi, hype, archype, ln, log, e to the x, 10 to the x inverse, x squared, x cubed, square root of x, y to the power of x, x root, cube root, n factorial, NPR, NCR, and percent. All right, so sine 60, 0.866, that's correct. Okay, so cos pi on 4 radians. So set up 0, 1. That's not right. Oh yeah, it is 1. Okay, so set up 0, 1, puts it in radians mode. Very good. So then we press cos, open bracket, pi. Where is pi? Where is pi? There is pi. Pi. Divided by 4. Close bracket, which is optional, I think. So 0707, that's correct. And it was, the close bracket was optional. It doesn't write it in there for you. It just calculates. Okay. All right, now we're going to do inverse tan. Okay, so set up 0, 2. Okay, it's in gradients. Okay. We're going to do tan, inverse tan, second function tan 1 equals, okay, that's 50, okay, and then set up 0, 0 puts us back in degrees mode, okay. So we've got cosh and cinch, so we press where is conch? So we press on, clear it, and press open bracket, hyperbolic cos 1.5 plus hyperbolic sine 1.5 all squared, close bracket, x squared equals 20.085. We got that correct. Okay. So that's okay. That's cosh, the hyperbolic functions. So you just press hype and then what function you want. Very good. So let's do tan, inverse tan. So second function. Oh, that's tan h to the minus 1. So it's second function archype tan open brackets 5 divided by 7 close brackets equals 0.895. Okay, so to get the inverse tan h, you press second function archype tan minus 1. Okay, wow. All right, now we've got ln20, so you just press ln20, that's easy. Value 2.99. Log 50, just press log 50 equals 1.69, e cubed. So second function, e to the x is 3, enter, 20.08. 10 to the power of 1.7. So we go, second function, 10 to the x. There it is. 1.7, and we get 50.11, correct? All right, now if we want to do 1/6 plus 1/7, so we can just do 6, second function, x to the minus 1, plus 7 x to the minus 1 equals 0.309. Very good. I'm going to take a quick break. I'll be back. All right, I'm back, and on we go. So what did we just do? Inverse 6, inverse 7. All right. So let's do 8 y to the x minus 2 minus 3 to the power of 4 times 5 squared equals minus 20.24. Oh no, that's not 0.24. That's minus 2024. That's right, 2024. All right, cool. And then we can do 12 cubed to the power of 1/4. So we do 12. Okay, I don't know why we don't use x squared, x cubed there, but it says to use this, so we will. 3 y to the x 4 second function inverse equals 6.44. Okay. 8 cubed, so we can just do 8 cubed. 512, that's right. Okay, the square root of 49 is the square root of 49 divided by the fourth root of 81. So second function, square root, yeah, 49, square root 49 minus 4 second function x root. Okay. 81 equals 4. Yep, good. So is that must be 7 minus 3, is it? 4 there, 81, 3. Yeah, 3 times 3 is 9, times 3 is what, 27, times 3 is 81. I think that's right. So cube root of 27, the second function, cube root, 27, 3, very good. 4 factorial, 4 factorial, where is it? There it is, second function 4, enter, 24, very good. Okay, 10p3, 10, second function, npr, 3 equals 720, and 5c2, 5c2, 10. That's right. Of course, P is for permutation, C is for combinations. So that's 10. If we did 5p2, 5p2, it's 20. So there's twice as many permutations as there are combinations in that example. Okay, we've got 500 times 25%. So we go 500 times 25 second function percent, and we get 125. What have I done wrong? 500 times 25% equals. No, I've done something wrong. $500 times 25 second function percent, 125. Okay, you don't press equals. you just press percent and you get the answer, 125. All right, that's good to know. 120 divided by 400 percent. The answer is 30. Oh, I see. We've got 500 plus, open brackets, 500 times 25%, close bracket. Oh no, that's, I did that quite wrong. 500 plus 25%, 625. There you go. And then 400 minus 30%, 280. Okay. The range of the results of inverse trigonometry functions. The range of the results of inverse trigonometric functions. For degrees, theta can be between minus 90 and plus 90 for sine and tan inverses. For cos inverse, the degrees can be between 0 and 180. Radians, okay, and then the same values are given in radians and gradients, of course. Okay, cool. So the inverse trig functions, sine inverse, tan inverse, and cos inverse, they convert a value into the angle that, when applied to the trig function sine, tan, or cos, results in that value. Yeah. So the ranges, because they're periodic, they can only be in these ranges. Very good. So on we go over here. So what did we just do? Functions number 5. So we're up to 6, which is, okay, differential and integral functions. Okay, that's interesting. Differential and integral calculations are only available in the normal mode. For calculation conditions such as the x value in differential calculation or the initial point in integral calculation, only numerical values can be entered, and equations such as 2 squared cannot be specified. It is possible to reuse the same equation over and over again and to recalculate by only changing the conditions without re-entering the equation. Performing a calculation will clear the value in the X memory. When performing a differential calculation, enter the formula first and then enter the X value in differential calculation and the minute or minute interval, minute interval, dx. Okay. If a numerical value is not specified for the minute interval, x not equals 0 will be absolute value of x times 10 to the minus 5, and xo will be 10 to the minus 5 from the value of the numeric derivative. When performing an integral calculation, enter the formula first and then enter a range integral AB and subintervals n. If a numerical value is not specified for subintervals, calculation will be performed using n equals 100. Since differential and integral calculations are performed based on the following equations, correct results may not be obtained in certain rare cases when performing special calculations that contain discontinuous points. So the integral calculation using Simpson's rule is given here. Okay. I'm going to take a quick break. I'll be back in a minute. All right, I'm back, and I got myself a fresh coffee, and I've drunk most of it already. What are we up to? What are we up to? Differential function, Simpson's rule. All right, so Simpson's rule is this monster down here. Do you want to see it up close? I'll see if I can show that to you. It's probably not visible. This is it here. 1/3 HFA, 4FA plus H plus FA plus 3H, where H equals B minus A on N, N equals 2N, A is less than equal to X is less than equal to B. Differential calculation. So they use a value for dx, and yeah, okay. Anyway, it's just telling you how the calculator goes about calculating integrals and differentials, which is done with numerical methods, and you have to pick an epsilon value, which is, it's all well and good. Okay, when performing integral calculations, integral calculations, depending on the integrands and sub-intervals included, require longer calculation time. During calculating will be displayed. To cancel the calculation, press on/C. Note that there will be greater integral errors when there are large fluctuations in the integral values during minute shifting of the integral range, and for periodic functions, etc., where positive and negative integral values exist depending on the interval. For the former case, divide integral intervals as small as possible. For the latter case, separate the positive and negative values. Following these tips will allow results of calculations with greater accuracy and will also shorten the calculation time. Okay, so they're gonna give us some examples in number 6. So what does that look like? Okay, so let's jump over to the examples, and we're going to be doing this one here. Give ourselves some space. All right, this is the one here, number 6. Which is regarding the ddx and integral dx. All right, so okay, so we're going to find the derivative at x equals 2 with epsilon equals 0.00002. All right, so let's press alpha x. Where's alpha? There it is there. Alpha x. Where is x? Here. Alpha x, y 4 minus 0.5 alpha x cubed plus alpha x oh no, I got that wrong. Let's try del. Okay, we've got 0.5 x cubed, 0.5 x cubed plus 6 alpha x squared plus 6 alpha x squared. And then do I press equals. Okay, error 1. Oh, no, I see. All right. Can I go up? No, I seem to have lost that completely. All right, let's try again. Alpha x to the power of 4 minus 0.5 alpha x cubed plus 6 alpha x squared. Second function, and we're looking for the ddx. Where is that? It's not jumping out at me. There it is. ddx 2, that's x equals 2. Enter, and then the value for dx is given as a default value here, and we press enter and we get 50. All right. And then if we press enter again, we can enter a new value for x as 3, and we can change the dx value to 0.001 and press enter, and we get 130.5. Great. All right, I'll be back in a sec again. All right, so we saw our integral at x equals 2 and x equals 3. Oh, sorry, our derivative. We calculated the derivative at 2 points for x. What we're going to do now is an integral. So we press alpha x squared minus 5, and then we press the integral button, which is here, and a is 2, and asking for b is 8. Enter. N, we press enter, we get a 100 n by default, and I was expecting to see 138. Let's try that again. So alpha x squared minus 5 integrate 2, enter, 8, enter, n, 100, enter. Okay, it is not working. I'm going to go away, play with this. I'll come back in a sec. All right, let me show you what I just figured out. If we look at this now, we see that it's showing 0, and we've got the solar panel at the top here. Now, if we put our thumb over the solar panel, the number completely disappears. When it's forced to run on battery, it can't. And we bring that back, and the solar power is enough to show the 0, but it's not enough to actually do some number crunching. So that's why we're seeing this weird behavior. Isn't that silly? So let's replace the battery together. All right, so this is the battery that we took out, and if we just stick it in here, oh, wow, it's dead as a doornail. So let's put that in there. And before we put in our new battery, we'll just test it to see. Oh, got it the wrong way around. It's not giving me a good reading. I don't know why. I'll be back in a minute. All right, I'm back, and I don't know if you can see. Let me see if I can zoom you in here. So the reading that we're interested in is the bottom one, which is in the green. The top ones for the other cells, the battery mini cells are the bottom ones. So that says battery good, which is well and good. So let's pop him in, and then we'll do our little solar panel test again. That seems to be working great. All right, I'll put this back in. Screw the battery cover back in. All right, so we're back in business, and let's try the old solar panel cover up. So how will we do that? Just with my thumb will do. And we cover the solar panel, and it keeps working. There we go. So if you see some weird dropout behavior, be sure to check the battery. There we go. So that was definitely traps for young players, wasn't it? All right. So let's try our calculus again. We were calculating the integral. So let's do that together now. The integral is here, and this is our thing, and we'll put it back there. How's that? Pretty good. Pretty good. All right. So it's alpha x squared minus 5. And then we press the integral button, and then we enter 2 for A, and we enter 8 for B, and N at 100, and the result, it says calculating, the result is 138. And we can press enter, 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 and put it down to 10 for N, and press enter, and we still get 138. And it did seem to be a bit faster, didn't it, with N equals 10 instead of N equals 100. Very good. So on we go. So that was our differential and integral functions. Oh, there's more talking about. Oh no, I think we read this. Yeah, we did. Okay, cool. So we're up to the random function. There's no example for the random function. The random function has 4 settings for use in the normal, statistics, matrix, and list modes. Okay. This function cannot be selected while using the n-base function. To generate further random numbers in succession, press enter. Press on/C to exit. The generated pseudo-random number series is stored in memory in memory Y. Okay. Each random number is based on a number series. Okay, random numbers. A pseudo-random number with 3 significant digits from 0 up to 0.999 can be generated by pressing second function random 0 enter. Okay, let's do that. Second function random and then 0 and enter. Okay, we got 0.994. You can do random dice. To simulate a die rolling, a random integer between 1 and 6 can be pressed by pressing second function random 1 enter. Alright, second function random 1 enter. And we got the value 2. Random integer. An integer between 0 and 99 can be generated randomly by pressing second function random 3 enter. Alright, so we've got second function random 3 enter, and it gave us 81. Okay, there you go. Now we're up to angular unit conversions. Each time second function drg are pressed, the angular unit changes in sequence. Okay, and there's an example here, so we'll have a look at number 7. Look up here. So this is 7 over here. Shows us how to use DRG. So we can press 90. Give us some space. We're doing 7 here. Press 90. Second function DRG. Here it is down here. So that'll convert 90 degrees into radians. Okay. And then we press second function DRG again. It'll put it into gradients. And then we put it in DRG again, and it's back to degrees. Very good. All right, and they're going to give us an example with the inverse sine function at 0.8. So let's press second function sine 0.8 equals. So it's 53.1. Yep, that's right. Oh, I bumped the desk. So it's 53.1, and then we can switch it to radians by pressing this, and we get 0.92. Then we can switch it to gradients, and we get 5.9. And then we press degrees, and it's back to degrees, which is 53.1. Great. So after angular conversions, we've got memory calculations. Okay. So in normal mode, answer memory, M, F1 to F4, and AF and XY are all available. In stats mode, only answer is available. In equation mode, nothing is available. Complex mode, everything except for AF, XY is available. In matrix mode, there is no M or F1 to F4, but there is the others. Same for list. Okay. Temporary memories. So the memories A to F and X and Y are called temporary memories. Press store and a variable key to store a value in memory. Press recall and a variable key to recall a value from the memory. To place a variable in an equation, press alpha and a variable key. Okay, great. Independent memory, M. In addition to all the features of temporary memories, a value can be added to or subtracted from an existing memory value. press on store M to clear the independent memory M. Okay. Last answer memory. The calculation result obtained by pressing equals or any other calculation ending instruction is automatically stored in the last answer memory. A matrix list format result is not stored. Okay, and then there's formula memories, F1 to F4. Formulas up to 256 characters in total can be stored in F1 to F4. Functions such as sign, etc., will be counted as one letter. Oh, that's interesting. Storing a new equation in each memory. Storing a new equation in each memory will automatically replace the existing equation. Note, calculation results from the functions indicated below are automatically stored in memories X or Y, replacing existing values. Okay, so I don't know why they've got that note under formula memories, because it seems to be affecting the Y or the X memory. Fair enough. Calculation results from the functions indicated below are automatically stored in memories X and Y, replacing existing values. The random function gets stored automatically in the Y memory. And okay, if you convert to polar coordinates or you convert to rectangular coordinates, the X memory has the left value and the Y memory has the right value. Okay, and use of RCL or alpha will recall the value stored in memory using up to 14 digits. Okay, good. Now there is an example here, number 8, so let's throw you over to that. What do we got here? Number 8. This is 8 up the top here. All right. So let's do this. This is going to show us how to use alpha, recall, store, M plus, M minus, answer, F1, F2, F3, and F4. It's pretty extensive, isn't it? So let's do 8 times 2 store M says 16. Okay. And then 24 divided by alpha M equals 1.5. Very good. And then alpha M times 5 equals 80. Very good. All right, so we press store M, and that'll set M to 0. We'll do 150 times 3, and we'll press M plus. Okay, and that'll give us 450. And then we do 250 M plus. Okay, that has replaced the value. Okay, and then we can press recall M times 5. Second function, percent 35. Second function, M minus. Why am I not seeing M minus? Oh, there it is there. Recall M 665. So what did we do? We did 250 times 5%. Oh, okay. And then we subtracted. I'm not sure what we did there. That was a bit confusing for me. I don't know how we got to 665. Yeah, I'm a bit confused about what happened there. I'm going to take a break. Okay, well, I had my break. I just ran this example again to try and understand it. And there is actually some helpful remarks here about M1 and M2, which I hadn't appreciated. So let's run through the whole thing together. So when you press store M, that puts 0 in the M memory. And then you press 150 times 3, and you press M plus, and that will put 450 in the M variable. So we should be able to recall M, and it'll be 450. And then we can press 250 M plus, which will add 250 to what's in M. So if we recall M, we get 700. And if we do recall M times 5%, 5% of 700 is 35. I believe that's correct. We can just check. 700 second function. Oh no, 700 times 5%, 35. Very good. So we can recall M times 5% is 35, and then we memory minus, and then we recall M, and it's 665 because 700 minus 35 is 665. So there you go. That's that explained. All right, we've got some more examples here. So that was demonstrating M. Okay, so we're going to okay, we're storing a exchange rate. By the looks of it, it's yen. So $1 is 110 yen. I'm pretty sure that's what that is. I don't use yen very much in my day-to-day. 110 store Y, and then 26510 divided by recall Y equals, what are we dealing with there? 241, and then 2750 times recall Y equals. So that's just showing how to use the exchange rate to convert yen and dollars. Very good. So what's next? We're going to be using Y to calculate okay. So 3 store Y, and then pi alpha y squared equals. All right, so we stored a radius of 3 centimeters, and then we calculated the area of the circle with that radius, and we stored the r in the variable called y. Very good. Now what are we doing here? 24 divided by 4 plus 6 equals 2.4 dot 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 a. 3 times a plus 60 divided by a. All right, so let's do 24 divided by, open brackets, 4 plus 6, close brackets, equals, and then 3 times alpha and plus 60 divided by alpha and equals, and we've got 32.2. There you go. So you can press alpha ands to get the variable answer. Very good. And you can store an expression in F1 using pi alpha y squared. So we've got pi y squared, and we can store it into F1. So we press store F1. Then we press 3 store y and recall F1 times 4 divided by 3 equals 37.699. Great. Okay. So you can store a formula using these formula keys, and those formulas can refer to variables, including, in this case, y and others. Okay. So that was talking about various memories, including how to use the formula memories. So now we're up to chain calculations. The previous calculation result can be used in the subsequent calculation. However, it cannot be recalled after entering multiple instructions or when the calculation result is in the matrix or list format. When using postfix functions, such as the square root, sine, etc., a chain calculation is possible even if the previous calculation result is cleared by the use of the on/C key. All right. Shit, I forgot to show you. Yeah, we're looking here at the chain calculations down the bottom there. So let's jump over to number 9 here. All right, so this is going to give us some examples of chaining answers through. So we press 6 plus 4 equals 6 plus 4 equals, and then plus 5 equals, and that's 15. Okay. So, okay. That's what they mean by chaining, is you don't have to actually say answer. So 8 times 2 equals, put 16 in the answer, and 16 squared is 256. and then we do 44 plus 37 equals, and that puts 81 in the answer, and then we can use square root, so that's here, second function, square root equals 9. Cool. All right, so back over to the operation manual. We've just completed 9. We're up to 10. Fraction calculations. All right, we're doing this here. Fraction calculations. Arithmetic operations and memory calculations can be performed using fractions and conversion between a decimal number and a fraction. If the number of digits to be displayed is greater than 10, the number is converted to and displayed as a decimal number. Okay, so arithmetic operation and memory calculations can be performed using fractions and conversion between a decimal number and a fraction. Okay, cool. And if it's too big, you don't get a fraction, you just get a decimal, and that's that. So they're going to give us an example in number 10. So let's switch you over here to number 10. This is 10 here. It looks like it's fairly involved, actually. All right. So 3.5 plus 4/3. So we do 3 and ABC, 1 ABC 2 plus 4 ABC 3 equals, and we get 4, 5, 6. And then we can press just ABC. Okay, great. And that'll convert it into a decimal. And we can press it again, and it'll turn it into an improper. How do we get it to show? Maybe if we do it like that. Yep. So you press second function DC, it'll show it as an improper fraction. And if you just press this, it'll decimal and mixed fractions. Very good. So let's do 10 to the power of 2/3. 10 to the power. Oh, no. Let's just do what it says. Second function, 10x squared ABC three equals, and we get 4.6. Okay, so you can say 10 to the power of 2/3, 4.6. And can we switch that to a fraction? No, this is an example of a number that you can't put into fraction mode. Fair enough. I'm just going to take a break. I'll be back in a sec. All right, there's a bunch more examples to go through for section 10, which is showing us how to use the various fractions and mixed fractions. So let's do 7 ABC 5 ABC 5 equals. What have I done wrong? Oh, I see. Dear me. Okay, so we press 7 and 5, and that'll be 7 divided by 5. And we want to put it to the power of 5. Okay. And press equals, and it gives us an improper fraction. So we should be able to convert that to a decimal value and an improper fraction. And if we press second function, it doesn't seem to want to give it to us in mixed fraction, does it? Okay, there you go. So it will give it to us in decimal format, but it won't give it to us. Maybe that's because there's not enough space. Yeah, right. If you tried to show that as a mixed fraction, you wouldn't be able to fit it on the screen. All right, so let's do 1 on 8 to the power of 1 on 3 equals a half. Very good. And we've got the square root. Okay, we've got the square root of 64 over 225 equals 8/15. That's cool. Wow. And then we've got you can use it for, okay, so if we press open brackets 2 to the power of 3 close brackets fraction open brackets 3 to the power of 4 close brackets equals 8 on 81. That's pretty cool. And if we press this, it should toggle into decimal mode, and it does. Great. All right. And then we've got 1.2 divided by 2.3. 1.2, 2.3 is 12/23. Great. All right. And we can do 1 degrees, 3 minutes, and 1 degrees. I pressed the wrong button. So we do 1 degrees, 2 minutes, 3 seconds over 2 equals 0 degrees, 31 minutes, and 1.5 seconds. Wow, okay. And then we've got 1 EXP 3 over 2 EXP 3 equals a half. Very good. And we should be able to turn that to 0.5. We can. And we're going to store a value in A. So store A. Store A. Oh, I forgot to put the value. 7 store A. And then 4 ABC alpha A equals 4 divided by 7. Very good. And then there's 1.25 plus 2 over 5 equals 1.65. And we can convert it back to a fraction, and it'll give us in 1, 13, 20, and we should be at, oh, I pressed home. I meant to press second function. Let's do that again. So 1.25 plus 2 over 5 equals, so it gave gave us a decimal. We can press that to put it into a mixed fraction, or we can press that and put it into improper fraction. Great. There's an asterisk here. What's that for? Asterisk. I'm not sure. Oh, there it is there. Okay, yeah, so it's just saying that 4 and then that angle, and then 5 and then the angle, and 6 is the same as the mixed fraction given there. Very good. All right, so let's go back over to the instructions. And we just finished number 10. So we're up to binary and so on. I'm going to take a long break. I'll be back to continue with these with this operation manual soon. You won't even know that I've gone. I'll be back later. All right, on we go. We're up to binary, pental, octal, decimal, and hexadecimal operations called n-base. Of interest is the pental. They've got base 5 in there now, so that's a new one since the old sharp calculator that I have. So we'll read it and then we'll have a look at the calculation example. Conversions can be performed between n-base numbers. The 4 basic arithmetic operations, calculations with parentheses, and memory calculations can also be performed, along with logical operations and or not, neg, XOR, and XNOR on binary, pental, octal, and hexadecimal numbers. Okay. Conversion to each system is performed by the following keys. So second function bin, B appears. Second function pen, P appears. Second function oct, O appears. Second function hex, H appears. Second function dec, P, B, P, O, and H disappear. Note the hexadecimal numbers A to F are entered by pressing pi x to the y to the x, x squared, x cubed, log, and ln, and displayed as follows. So A is shown as basically the 7-segment display equivalents of A, B, C, D, E, and F. In the binary, pental, octal, and hexadecimal systems, fractional parts cannot be entered. When a decimal number having a fractional part is converted into a binary, pental, octal, or hexadecimal number, the fractional part will be truncated. Okay. Likewise, when the result of a binary, pental, octal, or hexadecimal calculation includes a fractional part, the fractional part will be truncated. In the binary, pental, octal, and hexadecimal systems, negative numbers are displayed as a complement. Okay, and I assume that's 2's complement. But there is also 1's complement, and it didn't say which one it uses. 2's complement, probably. So let's have a look at the calculation example for number 11. We'll zoom you in here. What have we got? Number 11, which is here. Oh, it's quite extensive. It goes on up here. We'll move that down when we're ready. So we're just going to go through this part here first. So, turning 25, second function, decimal, and then 25, and then just second function binary, binary, and we've got 11001B. It's decimal 25 in binary. Cool. Now we're going to be doing hexadecimal, so we go second function hex, and we're going to put in 1AC, 1AC. You don't have to press alpha or second function, you just press the key. That's handy. Yeah. So I'm having trouble seeing the screen at this angle, but I can see it if I look on there, so that's something. All right. So converting it to binary, we just go second function bin, okay, and we get that long string. Looks about right to me. And then we can turn it into pencil. So that'll be second function pen, and we've got 3203. That looks right to me. And then we'll do octal, which is 654, and then back to decimal, or to decimal. We started with hex, didn't we? So the decimal value of 1AC is 248. Cool. So now we're going to do a binary subtraction. So we'll do a second function binary to put us in binary mode. Open brackets 1010 minus 100 times 11 equals, and we get 10010, which is correct. And then if we negate 111, what do we get? So where is neg? Let's go back here. Are we still in binary mode? Yeah, we are. Okay. Is this neg? No. I thought this was neg. What about if we just try pressing that? I'm looking for something called neg. I'm not seeing it. It says press neg. Neg. Oh no, you have to press it first. Neg 111 equals. Alright. Yeah, well that did what we expected. So, oh, there it is there. It's marked. So you can see just down the very bottom in the grey, it's marked as neg. So there you go. That is the neg key here, this one down the bottom. You have to press it before the number. So we're going to add hex 1FF and octal 512, and then get the output in hexadecimal. So we put ourselves in hex mode, and then enter 1FF, and then second function octal, and then plus 512 equals, that's an octal result, and we'll put it back in hex, and we get 349 hex, which is correct. Great. Alright, now we're going to do a straight up hexadecimal calculation. Sorry, so we'll make sure we're in hex mode, and we're going to do 2F E C minus 2000. Oh, we're putting it in so I've got it. We're using our memory variable, so I have to clear it first. So I press store store M. Alright. And then we're in hex mode, that's good. So we're going to end 2FEC, 2FEC. And then we're going to minus 2000, and then we're going to M plus and then we're going to put in 1901 or M plus, and then we're going to recall M, and we're going to get, oh, we didn't get what I was expecting to see. It says we should get A4D. Okay, let's try again. So we're going to go, are we in hex mode there? I think we are. So 2FEC minus oh, I see, 2C9E. So I just completely put in the wrong numbers earlier. I missed one. And we M plus, and then we go 2000 minus 1901 M plus recall M. (333) A. Dear me, I'm not having any luck with this calculation. Let's just try again. Alright, so I have to store M, that's what I forgot to do. So store M, that should set it to 0. Then we're in hex mode already, which is what we want. And we're going to enter 2FEC, and we're going to subtract 2C9E. And we're going to store that in M, and then we're going to add 2000, and then we're going to subtract 1901 and put the result in memory, and then we're going to recall M, and we've got A4D, which is correct. We finally got there. I have to say, I find using the negatives with the M plus key, I find that a little discombobulating. Anyway, we got the same result as the text, so that's something. There's a few more to do over here. So we're going to be doing a binary operation. So we'll put ourselves in binary mode, and we're going to add 1011 and where is and? Where is and? There should be a bunch of logic. There's an and key. Where is it? There they are up the top there. So they must just work in hex mode. So we just press and. This is and. The sign button is and 101 equals. Should be 1B, and it is. Okay. I'll just move it down so you can see what we're doing here. We're just working through these ones up the top here. So we just did 1011 and 101. So now let's do another hexadecimal calculation. So back in hex mode, and we'll do 5A or C 3 equals, is that dB? I think it is dB. Cool. So that'll be a bitwise and. I'm not going to think too hard about that. I'll take it as given. We can negate. So if we put ourselves in binary mode, which is here, put ourselves in binary mode, and then we use not. Okay, so we're in binary mode. So we're going to we're going to put not, there's not, 10110 equals, and it gives us a 2's complement value, 11111010001. Very good. So we're going to do an XOR in octal. So we'll put ourselves in octal mode, and we're going to have 24 or 24 XOR 4 equals, and we've got 20 in octal. And then we're going to do a hex function again. Second function, hex, and we're going to put in B3, and XNOR, okay, 2D equals, and it gives us this great big honking thing, and we turn it to decimal, and we get it as a negative number. Great. 159 minus 1.59. All right. So on we go. That was N base. Now we're doing time, decimal, and sexagesimal. I don't know how to pronounce that properly. Please excuse me if I'm getting it wrong. Conversion between decimal and sexagesimal numbers can be performed, and while using sexagesimal numbers, conversion to seconds and minutes notation. The 4 basic arithmetic operations and memory calculations can be performed using the sexagesimal system. Notation for sexagesimal is as follows. So I'll just show you that if I can over here. This is the notation. First is the degree, then there's the minute, and then there's the second. And the second comes with some decimal fractional digits after the decimal point. So the seconds can be decimal. Okay. Coordinate. Oh, okay, so that was 12. So they're going to give us some examples for 12, which are here. So we'll zoom you in there, and we're looking at these. So we'll plug them in here. You should be able to see that. Clear ourselves. Put ourselves back into decimal mode if we weren't already. I couldn't see. So this is 12. So we're going to enter 12 degrees, 39 minutes, and 18.05 and then, okay, you don't press enter, you just press degrees, which is this one, second function, degrees. And it gives us 12.65-ish. Okay. And then we can take a decimal, like 123.678. That's a decimal value, and we're going to convert it to degrees, so second function degrees, and we've got 123 degrees, 40 minutes, and 40.8 seconds. Very good. All right, now we can add some hour, minute, second values. So we go 3 degrees, 45 minutes, and 45 seconds, plus 0 degrees. What am I doing here? Oh no, I've entered the wrong thing. Sorry, I'll just start that again. So we do 3 degrees, 30 minutes, 45 seconds, plus 6 degrees, 45 minutes, and 36 seconds equals, and the result is 10, 16, 21. 10 degrees, 16 minutes, 21 seconds. Right, so we've added 3 degrees and 30 minutes to 6 degrees and 45 minutes, and the result is roughly 10 degrees, which stacks. Okay. Now we're going to use a number that's got more degrees than are in a circle. So it's 1, 2, 3, 4 degrees, 56 minutes, and 12 seconds, plus 0 degrees, 0 minutes, and 34.567 seconds, and the result is 1, 2, 3, 4, 5, 6, 4, 7, 56 minutes, 47 seconds. Alright, now we can do a calculation involving a subtraction. So we go 3 degrees, 45. Actually, I'll just do this and then I'll take a quick break. Actually, no, I'll take a break now. I'll be right back. Alright, on we go. So, just going to do this one that has mixed input between sexagesimal and just straight up decimal. So we've got 3 degrees, 45 minutes. No, I shouldn't have pressed that again. So it's just 3 degrees, 45 minutes minus 1.69 equals, and gives us a result in decimal, and we can convert it to degrees with this function here, and we get 2 degrees, 3 minutes, and 36 seconds. Very good. So we can do a sine function. Oh, okay. So we press sine, and then we press 62 degrees, 12 minutes, 24 seconds equals, and we get our result in base 10, 0.884. That's right. Okay. So we can just literally convert. So 24 degrees, and then we press math 3, equals. Okay, I'm not sure what we're doing there. Let's just do what it says. So it's 24 degrees, math 2, and we've got 86,400. Okay, what was math 2? Let's just hit math 2, seconds. Okay, so you can turn 24 degrees into seconds. Cool. And I guess we can go the other way. We can turn 0 degrees, 0 minutes, 1,500 seconds. Math 3, 1, 2, 3, and that will convert to minutes. 25 minutes in 1,500 seconds. Very good. All right, so that was about time, decimal, and sexagesimal calculations. we're now up to coordinate conversions. Okay, so throw you back over to the large thing. We're working through this. This is coordinate conversions. Before performing a calculation, select the angular unit. Okay, before performing, select the angular unit. Okay, so that'll be degrees, radians, or gradients. The calculation result is automatically stored in memories X and Y. The value of R or X, X memory, and the value of theta or Y, Y memory. Okay, cool. So there's a demo on 13. That's over here. I'll zoom you in on that. We're working through work example 13, and this is our calculator. You can see the whole thing. So we've got so it looks like we can input points using comma. So 6 second function, comma. I'm going to have to find that. I don't know the comma key. Where is the comma key? There it is. 4. 6 comma 4. So then second function re. There it is there. 8. Second function r theta. Error 1. Alright, let's try that again. 6. Second function comma 4. Okay, I must have pressed the wrong comma key earlier. And then we can second function r theta, and it goes to 7.2. That's correct. And then you can use the comma to switch between parts. So we press comma again. I was expecting that to show. Did I press it wrong? I'm not sure. So let's try that again. 6 second function comma 4. Second function r theta. That's r. And then second function comma. I don't know why it says maybe I just need to use the arrows. Let's try that again. So 6 comma 4 r theta. Did that work? Second function r theta. Okay, 7.2. And if we press left or right, it wants to edit the values. That's not what I wanted to see. Oh, there it is there. Okay. So I found the key. So there's a comma here, and there's a left or right comma here. Fine. So that was a bit confusing, wasn't it? All right. So 6 second function comma 4. Switch it to r theta. Why didn't that work? R theta 7.2, and then second function is okay. So the theta value is 33.69, and then if we press it again, we should get back to r. Okay, so we've got r 7.2 and theta 33.6, and they're going to give us another example. So it's 1 4 second function comma 36. Okay. Second function xy. Second function xy. we get 11.3, and then we can press the comma dot 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 or comma arrow, and that'll give us the y value of 8.2, and then we do it again and we get the x value of 11.3. Very good. So now we're going to calculations using physical constants. Okay. See the Italian manual reverse side. All right, this is the Italian manual, and this is the reverse side. And here are our constants. We've got our physical constants and metric conversions. Cool. I won't run through them in detail because it's going to ask me to pronounce things that I don't know how to pronounce. See the Italian manual reverse side. A constant is recalled by pressing second function const followed by the number of the physical constant designated by a two-digit number. The recalled constant appears in the display mode selected with the designated number of decimal places. Physical constants can be recalled in the normal mode when not set to binary, pental, octal, or hexadecimal, statistics mode, equation mode, matrix mode, and list mode. Note, physical constants and metric conversions are based either on the 2014 CO data recommended values or the 2008 edition of the Guide for the Use of the International System of Units SI released by the National Institute of Standards and Technology or on ISO specifications. Actually, I'll try and put a link to some of that in the show notes because it's actually quite interesting that these standards, they're like a beacon of scholarship. It's really quite remarkable how careful and how detailed and how comprehensive these reports are. They're just sort of erudite. They're amazing. Oh, that's good. So this is actually going to tell you how to pronounce them. So we've got over here, we've got numbers 1 through 52, and here they give the see if I can zoom you in a bit on that. So on the left hand side is what the units are typically associated and the symbols that are used, but here they give you the constant in English, so we will be able to just run through those constants. So we've got the speed of light in vacuum, Newtonian constant of gravitation, standard acceleration of gravity, on Earth of course that is, electron mass, proton mass, neutron mass, muon mass, atomic mass, unit kilogram relationship, okay, elementary charge, Planck constant, Boltzmann's constant, magnetic constant, electric constant, classical electron radius, fine structure constant, Bohr radius, Rydberg constant, magnetic flux quantum, Bohr magneton, electron magnetic moment, nuclear magneton, proton magnetic moment, neutron magnetic moment, muon magnetic moment, Compton wavelength, proton Compton wavelength, Stefan Boltzmann constant, Avogadro constant, molar volume of ideal gas, molar gas constant, Faraday constant, von Klitzing constant, electron charge to mass quotient, quantum of circulation, proton gyromagnetic ratio, Josephson constant, electron volt, Celsius temperature, astronomical unit, parsec, molar mass of carbon-12, Planck constant over 2 pi, Hartree energy, conductance quantum, inverse fine structure constant, proton electron mass ratio, molar mass constant, neutron Compton wavelength, first radiation constant, second radiation constant, characteristic impedance of vacuum, standard atmosphere. There you go. So that's 1 to 52 for the constants. Now there was some examples. What are we going to do? Oh, yep, there's just a couple here. There's not too many. So this is I'm not sure what we're calculating here. We've got V0 and time. And then we're going to add half GT squared and get the result in meters. Oh, okay, G. This is a Earth velocity acceleration problem. So let's do 15.3 times 10 plus 2 second function inverse, where is that? Here, times second function constant. Now where was that constant key? Here it is, constant, and we're going to enter 0, 3, okay, and then we're going to times 10 squared equals 643.3. So is that's the result in meters, I guess, and G is constant 3. What did it say, by the way, when we press second function const? And can we press left and right? No, but we press 03 and we get 9.8, which is what we'd expect for that. So that was just a simple little demo of a constant usage using the gravitational constant. Then we've got some metric conversions, and these are similarly named here and listed here. Okay, and there's 44 of them. So I'll just call them out again. Let me show you them. They're down the bottom here, just in this corner. And that's the units and such are shown here. And this is the thing. So metric conversions. Unit conversions can be performed in the normal mode when not set to binary, pental, octal, or hexadecimal. Statistics mode, equation mode, matrix mode, and list mode. Interesting. All right, so we've got to and from inch and centimeters, to and from feet and meters, to and from yard and meters, to and from mile and kilometers, to and from nautical mile and meter, to and from acre and square meter, to and from ounce and gram, to and from pound and kilogram, to and from degree Fahrenheit and degree Celsius, to and from gallon and litre, that's the US gallon, to and from the UK gallon and litre, to and from fluid ounce US and millimetre, to and from fluid ounce UK and millimetre, to and from joule and calorie, to and from joule and calorie 15 N degrees C. Oh, okay. So there's a temperature difference there. Okay, I don't know that. To and from joule and IT calorie. I think that might be the calories you count when you're eating food. I'm not sure. To and from horsepower and watt. To and from French horsepower and watt. To and from kilogram feet per centimeter squared and Pascal. To and from atmosphere and Pascal. To and from 1 mmHg equals 1 torr, and a Pascal, I don't know that unit. It's obviously a pressure though, if it compares with pascals. And then you can also convert from kilogram meter feet per meter, is it? F? I'm Not sure what F is. That it featured earlier as well. I don't know. And joules, whatever that is in joules. So, there was a demo. We might as well have a look at the demo. It's over here. Okay, this is converting yards to meters. So we'll just chuck it in. For example, we've got 125 second function convert, and we're going to pick conversion 5, and press equals, and we get 114.3 meters. So that's yards to meters. Cool. So I think we're on to the next page. So we got down to the bottom of metric conversions, and we're over the page onto calculations using engineering principles. I have to throw you out to the wide view. So we're reading here now, calculations using engineering prefixes. Calculation can be executed in the normal mode, excluding n-base, using the following types of prefixes. Okay, so you've got kilo, mega, giga, tera, milli, micro, nano, pico, femto. Okay, and the operation is manual 1. Sorry, math 1, and then a number from 0 to 8. So okay, that's pretty clunky, isn't it? Pretty clunky interface to, and the numbers are listed from, well, in different sort of orders. Anyway, they had to pick an order, I guess. So let's have a look at 16. All right. So here we're going to enter just the example of 100 m for for milli, I guess, times 10,000. Okay. So we got 100 math 1 4. Okay. And if you can see there, it's actually put the unit there. That's something. And times, and we're going to do 10 math 1 0 10k. So we've done 100 milli times 10k, and it should equal 1,000, and it does. Very good. So okay, now there's a facility to modify a function. So calculation results are internally obtained in scientific notation with up to 14 digits for the mantissa. However, since calculation results are displayed in the form designated by the display notation and the number of decimal places indicated, the internal calculation result may differ from that shown in the display. By using the modify function, the internal value is converted to match that of the display, so that the displayed value can be used without change in subsequent operations. Oh, that's interesting. Okay. So let's have a look at this. There's an example here. The example is number 17, which is just here. So let's do 5 divided by 9. Oh, actually, we have to do some setup first. So we're going to hit setup 1 for floating. I'm not sure what FSE stands for. It's to do with the precision. So we press 1 and then 0. So it's going to set it to fixed. And then we press setup again. And we press 2 for tab, which is the number of decimal places. And we enter a value from 0 to 9. We're going to use 1. Okay, so now we're in fixed decimal range. So we're going to go 5 divided by 9 equals, and round it off. Oh, that's not rounded. That's oh, is it? I'm not sure. Let's put it back in 1. How do we put it in normal mode? 3. If we do 5 divided by 9, what does that ordinarily equal? It's 5.5. 0.5 repeater, sorry, 0.5 repeater. Okay, cool. So that gets rounded off to 6 when we go setup 1, 0, setup 2, 1. Okay, and we do 5 divided by 9, and it's 0.5 repeater is rounded off to 0.6. There we go. If we do times 9 equals, we get 5.0. Right, because internally it used the correct value. Okay, that's interesting. And if we do 5 divided by 9 equals, and we put second function in MDF. Where is our MDF button? MDF. There it is. It's the 0 key. So we press second function 0. And then times 9 equals, and we get 5.4. Okay, cool. And then we go setup 1, 3, puts us back in normal mode. Okay, cool. So I hope that was clear. This is the MDF. I don't know what it stands for. MDF, modify function. MDF, maybe modified decimal function, or I'm not sure. All right, anyway, over we go. So we're up to solver function. The x value can be found that reduces an entered equation to 0. This function uses Newton's method to obtain an approximation. Depending on the function, for example, periodic or start value, an error may occur, error 2, due to there being no convergence to the solution for the equation. The value obtained by this function may include a margin of error. If it is larger than acceptable, recalculate the solution after changing start and dx values. Change the start value, for example, to a negative value, or dx value, e.g. to a smaller value, if no solution can be found, error 2, if more than 2 solutions appear to be possible, for example, a cubic equation, or if to improve the arithmetic precision. The calculation result is automatically stored in the X memory. Okay, and then they give us an example of performing a solver function. So press mode 0. I'll zoom you in here. All right, so we're gonna press mode 0, put us in normal mode. Input a formula with an X value. Okay, so let's say x squared. So where is x? Here, x, alpha x squared. Okay, there we go. I've entered a math formula. Press math 0, solve, and then input a start value and press enter. Okay, I'll start at 2. and then input a dx value. I'll just use 0.001. Okay, and press enter. Error 2. Ah. Huh. I would have thought I'd be able to solve that. Let's do the example that it gives us on the sheet. So this is solver function number 18. So we're back over here now on 18. I'm going to solve sine x minus 0.5. Okay. So sine alpha x minus 0.5, and then math 0, and then start at 0, and then just use the default dx, and it's calculating, and it gives x equals 30. Okay, and then if we enter 180 and enter, we get 150. Okay, cool. So up next is simulation calculator. Okay, this is part of the algebraic function. Cool. So if you have to find a value consecutively using the same formula, such as plotting a curved line for 2x squared plus 1, or finding the variable for 2x plus 2y equals 14, once you enter the equation, all you have to do is to specify the value for the variable in the formula. Use variables a to f, m, x, and y. Unusable functions. The random function is unusable. Okay, cool. Simulation calculations can only be executed in the normal mode. Calculation ending instructions other than equals cannot be used. That's interesting. All right, performing calculations. First, press mode 0. All right, so mode 0 puts you in normal mode. Input a formula with at least one variable. So let's try our x squared again, huh? So alpha x squared. Press second function algebra. All right, second function algebra. A variable input screen will appear. Enter the value of the flashing variable. Okay. Then press enter to confirm. So we'll set it at 2. And it solves for x squared equals 4. Okay. We should be able to do it with, let's try x plus 2y. So we go alpha x plus alpha y times 2. No, I pressed alpha x again. Oh, no, I did y. So that's x plus y times 2. And x equals 2. I'm not sure what I've done there. So let's press second function algebra. Enter a value for x, we'll use 2. Enter a value for y, and we'll choose 2. And we get 6. Right. Okay. So I see it doesn't algebraically solve the equation. It just allows you to use variables. Cool. So as it says here, the variable input screen will appear. Input the value of the flashing variable, then press enter to confirm. The calculation result will be displayed after entering the value for all used variables. Only numerical values are allowed as variables. Input of formulas is not permitted. Upon completing the calculation, press second function algebra to perform calculation using the same formula. Okay, cool. Variables and numerical values stored in the memories will be displayed in the variables and numerical values stored in the memories will be displayed in the variable input screen. To change a numerical value, input the new value and press enter. Performing simulation calculation will cause memory locations to be overwritten with new values. Right, so when you edit those variables, they literally update the variable memories. Very good. Now they did have an example here, number 19, so let's find that. Here it is down here, just a simple one. So let's zoom in there. I'll just show you that there is what we're doing now. So let's clear the calculator, and so we're going to enter fx equals x cubed minus 3x squared plus 2. So we'll make sure we're in mode 0, and then we press alpha x to the power of 3 minus 3 alpha x squared plus 2. Second function, algebra, 1 negative equals, and we get minus 2. And second function, algebra, and 0.5 negative equals, and we get 1.125. Okay. Obviously, we're going to do a different equation, and it's going to use variables a and b. So let's do second function square root. So just the normal square root, yeah. Open brackets, alpha a squared plus alpha b squared, close brackets. Second function, algebra, a equals 2 and b equals 3, and the result is 3.6. Very good. And we can second function algebra again, and we could a equals 2 and b equals 5, and we get 5.3. Very good. So that was simulation calculations. Now that we can do statistical calculations, so those are down here. Press mode 1 to select the statistics mode. Actually, before we continue with statistical calculations, I'm going to take a break. I'll be back in a minute. Alright, so we're a bit more than halfway through. Up next is statistical calculations, simultaneous linear equations, quadratic and cubic equation solvers, complex number calculations, matrix calculations, list calculations, and some information about error and calculation ranges. And then there's a section on battery replacement and some specifications. So that's basically this whole page to go, starting here. So press mode 1 to select the statistics mode. The 7 statistical calculations listed below can be performed. After selecting the statistics mode, select the desired submode by pressing the number key corresponding to your choice. To change statistical submode, reselect statistics mode by pressing mode 1, then select the required submode. 0 for SD, single variable statistics. Okay, SD, single variable. Is SD for standard deviation? I don't know. Or single data, maybe. I'm not sure. SD, single variable statistics. 1 line, linear regression calculation. 2 quadratic regression calculation. 3 exponential regression calculation. 4 logarithmic regression calculation. 5 power regression calculation, and 6 inverse regression calculation. The following statistics can be obtained for each statistical calculation. Refer to the table below. Alright, we'll get to that table in a minute. Single variable statistical calculation. Statistics of 1 and value of the normal probability function. Okay. Linear regression calculation. Statistics of 1 and 2. And in addition, estimate of y for a given x. Estimate y prime and estimate of x for a given y. Estimate x prime. Exponential regression, logarithmic regression, power regression, and inverse regression calculation. Statistics of 1 and 2. It hasn't told us what 1 and 2 are. They're probably lists, variables maybe, or pairs of variables, or I don't know. In addition, estimate of y for a given x and estimate x for a given y. Since the calculator converts each formula into a linear regression formula before actual computation takes place, it obtains all statistics except coefficients a and b from converted data rather than entered data. I'll read that again. Since the calculator converts each formula into a linear regression formula before actual calculation takes place, it obtains all statistics except coefficients a and b from the converted data rather than entered data. Quadratic regression calculation, statistics of 1 and 2, and coefficients of a, b, c. In the quadratic regression formula, y equals a plus bx plus cx squared. For quadratic regression calculation, no correlation coefficient r can be obtained. When there are two x prime values, press second function comma. Okay. When performing calculations using a, b, and c, only one numeric value can be held. Oh, I see. So those numbers 1 and 2 relate to particular variables. The following statistics can be obtained for each statistical calculation. Refer to the table below. Okay, so they're broken into section 1 and section 2. Section 1 includes mean of samples, X data, sample standard deviation from the X data, population standard deviation from the X data, number of samples, sum of samples, X data, sum of squares, X data. Then we've got mean of samples, Y data, sample standard deviation, Y data, population standard deviation, Y data, sum of samples, Y data, sum of squares of samples, Y data, sum of products of samples. Okay, that's the first one that's not available earlier because it uses X and Y values. R is the correlation coefficient, and then A, B, and C are coefficients. A is coefficient of regression, B is coefficient of regression, and C is coefficient of quadratic regression. Okay, and they gave that example earlier, y equals a plus bx plus cx squared. Use alpha and recall to perform a stat variable calculation. Okay. So maybe they'll give us an example how to do that in 20, which we're up to now. So let's pop over here. Where is 20? Oh, 20 looks like it might be huge. Where does it start? It starts up the top here. So we did this earlier. Okay, this was algebraic, and now we're up to statistical calculations 20. All right, let me just flip you over here. We're working through 20, which is all along here. It's pretty long. starts up there. All right, I'll give you a view of the calculator. All right. So this is how to enter the data by the looks of it. So it's showing us how to input the data. On we go. So we've got to go mode 1, 0. Okay. And we're just going to enter some data. Now, where is data? Data. There it is there. All right. So it's 95 data, 80 data. Okay, it seems to give us N after the data. Very good. And data again, we'll put 80 again. Very good. And then 75. Oh, that's interesting. We can put in an XY value. 75, XY, 3, data, 50, data, N equals 5. Okay, so recall X bar, which is the mean. So recall, I'm looking for X bar. Here it is. All right. So we got 75.7, that's right. And then recall sigma x, recall sigma x, 12.3, that's correct. N, recall N, there it is. What is it? 7, is that right? It must be counting the XY value twice. 1, 2, 3, 4, 5, 6. So I'm not sure why we get N equals 7. N equals 7. Okay. I thought 1, 2, 3, 4, 5, 6, 7. Oh, yeah, okay. 1, 2, 3, 4, 5, 6. Oh, I see. That's 75. 3. That's 3 times. 75 3 times. Okay, cool. That makes a lot more sense. I thought it put a tuple in the variable slot, but it didn't. So it's just 75 by 3. That's good. Okay, great. Sorry about the confusion. So that's N, 7, very good. Sum of X, so recall sum of X. Where is that? I'm not seeing sum of X. There it is. All right. Oh, why does it say 2? I'm not sure what I've done wrong. I don't know if my data is still in memory. Maybe it is. I don't know. What about a recall N? Oh, that still says 7, so maybe it's still there. So recall sum of X. Recall sum of X. 530, that's good. That's what I wanted to see. All right, recall sum of X squared. That's 41,200. That's correct. Recall SX. So that's the standard sample standard deviation. Recall SX. And we got 13.3, that's right. And then SX squared, recall SX squared. I'm not seeing that. Oh, I see. You can just square the... Okay, so you've got SX and you square it. You just press squared and it'll give you 178. That's right. Cool. All right, now we can do open brackets 95 minus alpha okay, alpha and then the mean, and then close brackets divided by alpha sx, which is here, times 10 plus 50 equals, it's 64.4, that's right. So I'm not sure what we're doing there. We go math 1 for, is that permutations, probability? I'm not sure. 60. Math 0. Okay. Close brackets equals 0.10. Alright. I'm not sure about the maths behind this. Anyway, we'll do math 3, 0.5 plus or minus, close brackets, equals 0.69. Alright, we'll go on to the next ones in just a minute. I'll be back. Alright, on we go. And now we're switching into two-dimensional mode. So we're going to start by putting ourselves in mode 1, which is line linear regression. And our data comes in pairs. So we go 2 pair 5. And then we press data and data. Okay, that put it in twice. 12 pair 24. Data 21 pair 40 pair 3. Okay, that's cool. So that 3 is the multiplier. It's going to put in 3 entries. Enter. And we get n equals 4. I was expecting more. And then 15 pair 25 data, n equals 5. That's interesting. So recall A. Where is A? Over here. 1.05. Yep. Recall B. Recall B. 1.82. 1.82. So those are the coefficients of our linear regression. Very good. Recall R. Recall R. There it is. 0.99. And recall SX. Recall SX. That's the population, the sample standard deviation. And it's 8.5, that's correct. And recall SY, that's the sample standard deviation of the Y values. Right, so that's SY. It's not jumping out at me, there it is. 15.6, great. So X equals 3, okay, Y equals, Y prime equals, so we do 3 second function, Y prime, looking for Y prime. It's not jumping out at me. Can you see it? I can't see it. So just to be clear, we're pressing second function Y prime. Oh, there it is. Sorry, it's here. Y prime. And the result is 6.5. Very good. So that's given x equals 3, y prime equals 6.52. I don't know if that's, I don't know what that is. Some sort of measure of y given x. Some projection probably. I don't know. I'm no stats guru. Anyway, and if you want to do the same for y equals 22 and x prime, then you press 22, second function, x prime, and you get 11. Oh, no. Why did I get that wrong? Let's try that again. 22, second function, x prime, 11.4 it says. If we press second function and this one, no. All right, let's put us back in. Oh no, we're in mode 1.1, I think. Mode 1.1. All right, and recall n just to make sure our data's still in there. Recall n equals 0. I must have wiped the data. I'm not going to re-enter the data now. I'm not quite sure what we've done down here with oh, maybe it's because I pressed equals. Yeah, I shouldn't have pressed equals. That's what the problem was. We're going to put all that data back in. I suppose I will. So 12 y41 data 8 pair 13 data 5 pair 2 data. Shit, I'm taking it from the wrong place. All right, I'll just try and get this right. So 2. Oh, actually, have I got data in there now? Yeah, I've got 3 in there. I'll clear it. How do I clear? Second function, clear all. So recall n 0. Okay, I cleared it all. So let's try again. 2 pair 5 data 12 pair 24 data 21 pair 40 pair 3 data 15 pair 25 data recall n 7. That's what we want to see. Let's recall a. Recall a 1.05. Yep, that's good. Now we want to do 46 second function x squared, and the value is 24.6. That's right. Good. All right, we're on to the next statistical test, which is asking us to okay, so we mode 1, 2. Okay, this is in quadratic a regression. Okay, so 12 pair 41 data 8 pair 13 data 5 pair 2 data 23 pair 200 data and 15 pair 71 data. Should be n equals 5. Recall A, and we're getting 5.35. That's right. Recall B, we get minus 3.1. That's right. And we've got recall C, which is 0.5. Yep. And we can do this conversion again. So 10 second function y prime 2.4. No, 24.4, that's right. And 22 second function x prime 9.6. That's right. And if we use this, okay, we can see the I'm not sure what those are. They're a pair of values, are they? Yeah, not totally sure about the mathematics behind that, but that's the end of the demo. So over we go to matrix calculations. Oh no, no. Oh no, there's heaps more stuff to do. What did we just do? 2020. Okay. So we've only got through this part. Okay, we're up to data entry and correction. Okay, very good. So entered data are kept in memory until second function clear all or mode selection. Before entering new data, clear the memory contents. Data entry, single variable data. Data, and data XY, frequency data, to enter multiples of the same data, okay? Two variable data, data X, pair, data Y, data. And you can have data X, pair, data Y, pair, frequency data to enter multiples of the same data X and Y. Up to 100 data items can be entered. With the single variable data, a data item without frequency assignment is counted as one data item. When an item assigned with a frequency is stored as a set of 2. Sorry, I'm going to read that again slowly. Up to 100 data items can be entered. Very good. With the single variable data, a data item without frequency assignment is counted as one data item, while an item assigned with frequency is stored as a set of 2 data items. Okay. With the two variable data, a set of data items without frequency assignment is counted as 2 data items, while the set of items assigned with frequency is stored as a set of 3 data items. There you go. Data correction. Sorry, just to belabor the point about the two variable data, each variable counts towards the tally, and for both of them the frequency actually counts as well. So but the frequency probably never costs you more, because if you had 2, then that would be the same as one data item with duplicate frequency 2. And if you had 3, then you'd be getting 3 data items worth of space for 2 data items worth of data. Hopefully that was clear enough. Data correction. Correction prior to pressing data immediately after a data entry. Okay, so if you haven't pressed data, just clear the data with on/C, then enter the correct data. If you want to make a correction after pressing data, use up and down to display the previous data previously entered. Press down to display data items in ascending oldest first order. To reverse the display order to descending, press the up key. Each item is displayed with xn equals, yn equals, or nn equals. N is the sequential number of the data set. Okay. N is not the number of samples, mind you, it's just the sequential number of the data set. Display the data item to modify. Input the correct value, then press data. Using pair, you can correct the values of the data set all at once. Don't know what that means. To delete a data set, display an item of the data set to delete, then press second function CD. The data set will be deleted. When it uses the word data set, I think it just means a pair or a single sample. data set. I think it means sample because it doesn't clear the whole lot. I would have called the whole lot a data set. To add a new data set, press on and input the values and press data. Okay. So it's going to give us an example of how to do all of those things. We'll pop you over here. So this is 21 that we'll be working through now. So we're going to put our data in mode 10, statistics mode. Okay, so the data is 30, data 40, pair 2, data 50, data. Okay. And then to edit the data so that the 40s get converted to oh, I see. Okay. So we just press down and then down and then down, and we get x equals 2, and we press 45 pair 3, and then we press data, and then we press down, and then down, and press 60 data. All right, so that edited 30, 40, 40, 50 into 30, 45, 45, 45, 60. So if we recall n, we've got 5 values. That's right. And I wonder what the what's the average of those. Recall x 45. That sounds about right, doesn't it? Yeah, because 30 is 15 less, and 60 is 15 positive. So yeah, 45. That's the correct mean for this data. So I think we got that right. It's curious to note that the sample, when we changed the frequency data, it overwrote the space. It overwrote the 50, which was a separate data item. So that's pretty interesting. Okay, well, that's good to know how that works. So on we go. All right. So we're going to learn some statistical calculation formulas. So there's different types of regression over here, and they've got a regression formula. So the linear regression is y equals a plus bx. Exponential equals y. Sorry, exponential is y equals a times e to the power of bx. Logarithmic is y equals a plus b times ln x. Power is y equals a times x to the power of b. Inverse is y equals a plus b over x. And quadratic is y equals a plus bx plus cx squared. In the statistical calculation formulas, an error will occur when the absolute value of the intermediate result or calculation result is equal to or greater than 1 times 10 to the power of 100. The denominator is 0. An attempt is made to take the square root of a negative number, or no solution exists in the quadratic regression calculation. Okay, so now they're going to give us some examples in number 22. That's the last one on this page. I'm not sure if it goes across. No, it doesn't. Fits in. Great. So I'll throw you over here. We're looking at this example here, number 22. So what have we got? Oh, shit. Oh, I see. Okay, there are no examples here, but they're just showing you that okay. Well, okay, so just to be clear. Okay, so these are the functions that they use to compute the various bits and pieces. So they show you how to compute x bar, which is the mean, sigma x, which is the population standard deviation, Sx, which is the sample standard deviation. Then there's sum of x squared, y bar, sigma y, sy, sum of xy, sum of y squared. Okay, so those are the formulas used to calculate those variables. Nothing more to see there. All right, now 22 through 23, normal probability calculations. Okay, so we've got PT, QT, and RT will always take positive values, even when t is less than 0, because these functions allow the same principle used when solving for an area. Values for PT, QT, and RT are given to 6 decimal places. Sorry, I'm just over here reading through this bit here. I'll be back in a sec. All right, so the thing we're doing next are these normal probability calculations. There's P, Q, and R. Will always take positive values even when t is less than 0, because these functions follow the same principle used when solving for an area. Okay, that doesn't mean anything to me. Values for PT, QT, and RT are given to 6 decimal places. Okay, and there's a bunch of examples, so we'll run through those over here. It's 20 through 23. So we're on to the next page. 20, no, maybe not. 20, oh, okay. Through 23. Oh, dear me. We've already done this. Through 23. Okay, we haven't done 23. We have done that. There was nothing actually to do. Sorry, my bad. Okay. So we're going to finish here with 23, which gives us some examples of what the P, Q, and R values represent. I'll zoom you in on that because that makes it pretty clear what those functions are. I didn't mean to do that. What am I trying to do? There we go. All right, so up here, you've got PT. It's everything less than T. And then you've got QT, which is between 0 and T. And then you've got RT, which is everything beyond T. Yeah, and it varies for when T is less than 0. Okay, that's interesting. So when T is less than 0, you just get this bit. When T is greater, you get the whole bit. Okay, and if you want between 0 and negative T, you have to pass negative T. Okay, so hopefully that's clear. All of those graphs are pretty self-explanatory. It says here T equals X minus X bar on sigma X, which is X minus the mean divided by the sample standard deviation. No, the population standard deviation. The standardization conversion formula. Okay. So that was 20 through 23. We're back over here and we're continuing on simultaneous linear equations. And they're going to give us some examples in 24 and 25. So before we do that, let's read this section. This is simultaneous linear equations. Simultaneous linear equation with 2 unknowns, 2 VLE, or with 3 unknowns, 3 VLE, may be solved using this function. Type 1 for 2-value mode, it's mode 2,0. For 3-value mode, it's mode 2,1. If the determinant D equals 0, an error occurs. Okay. If the absolute value of an intermediate result or calculation result is 1 times 10 to the power of 100 or more, an error occurs. Coefficients A1, etc. Can be entered using ordinary arithmetic operations. Okay, good. To clear the entered coefficients, press second function clear all. Okay. And pressing enter when the determinant D is in the display recalls the coefficients. Each time enter is pressed, a coefficient is displayed in the order of output, allowing the entered coefficients to be verified by pressing second function enter. Coefficients are displayed in reverse order. To correct a particular coefficient being displayed, enter the correct value and press enter. Alright, so they're going to give us some examples on 24 and 25. So here it's 24 over here. I'll zoom you in. Okay. So the first one's 2 value and the second one's 3 value. So we go mode 2 0. That's what is it? Mode stat normal equation. So 2 is equation mode, and then it's a 2-value equation mode. Very good. So we've got our coefficients, A1, B1, A2, B2. So we get 2, enter, 3, enter, 4, enter, 5, enter, 6, enter, 7. Alright. And then we press enter x equals 1. Minus 1 it should be. It's not minus 1. Alright, we'll keep going. Press enter again. Gives us y. And enter 3. I don't know if we put the numbers in wrong. Mode 2 0. Alright. A1 2, enter. B1 3, enter. C1 4, enter. And then it should be A2. Yeah, A2. A2 is 5, enter. 6, enter. 7. And then if we press enter, okay, we get x equals minus 1, that's correct. And enter again, and we get 2. And we press enter again, and we get minus 3. I must have made a mistake with the data entry earlier because we're getting the correct results now. So we're going to do an example with the 3-variable linear expression. So we'll go mode 3 value. So that'll be 2, 1. Okay. A1. So we're just going to enter our values. 1, enter, 1, enter, 1, plus or minus, enter, 9, enter, 6, enter, 6, enter, 1. Oop, no, that's wrong. 1, negative. Enter 17. And we've got 14, enter 7, negative, enter 2, enter 42, and then we press enter and we get 3.23 for x, minus 1.6 for what was that, y, I guess. And we do a second function, enter, gives us 3.2. That's not what I was expecting to see. Shit. Okay, that explains that. My mistake. So if I clear And I just want to, what have I got here? We'll just run through the data again. Okay, so that's D3 is 42, and then we press enter. Okay, 3.2, Y is negative 1.6, and Z is minus 7.4. Cool. And the determinant is 105. Alright, 105? Yeah, cool. Alright. So that does this for solving linear equations. Obviously the matrices are full of coefficients for your various dimensions. Okay, so that was 24 and 25. Now we're up to quadratic and cubic equation solvers, 26. So quadratic, ax squared plus bx plus c equals 0, or cubic, ax cubed plus bx squared plus cx plus d equals 0, equation may be solved using this function. 1, quadratic solver mode 2, or 2, cubic equation solver mode 2, press enter after entering each coefficient. The result will be displayed by pressing enter after entering all coefficients. When there are more than 2 results, the next solution will be displayed. When the result is an imaginary number, xy, symbol will appear. The display can be switched between imaginary and real parts by pressing second function, comma. The results obtained by this function may include a margin of error. There you go. Alright, so let's have a look at the walkthrough for 26. That is over here. Okay. And there's our calculator. So we're going to put it in mode 2, mode 2, and then we've got 3, enter, 4, enter, minus 95, enter, enter, enter. C, okay, minus 95, x1 is 5, x2 is minus 6.3, and second function, enter, is x1. I don't understand. Why are we seeing x1 twice? I don't know. x2, x1, x2. Oh, okay, so that's just to get you back. Okay, and then we'll do the example of the cubic. Mode 2 and 3. Cool. So we've got 5, enter, 4, enter, 3, enter, 7, enter for x1, negative 1.2, x2, 0.21. Second function, okay. So what did that do? Oh, I see, it's showing the I. And second function, that's the real part, xy, and that's the imaginary part. And the xy indicates that we're in rectangular coordinates, I guess. Cool. And then there's another complex example. Oh, that's coming up. So that was the end of the cubic solver. Okay. So back over here. That was quadratic and cubic equation solvers. Up next is complex number calculations. To carry out addition, subtraction, multiplication, and division using complex numbers, press mode 3. To select the complex number mode, results of complex number calculations are expressed in two modes. When the second function xy, it's rectangular coordinate mode and xy appears. And the second type is second function r theta, which is polar coordinate mode, and r theta appears. Okay, complex number entry. If you want to enter rectangular coordinates, you do x coordinate plus y coordinate I, or x coordinate plus I, y coordinate. Okay, or polar coordinates, you press r angle theta. R is the absolute value, theta is the argument. On selecting another mode, the imaginary part of any complex number stored in the independent memory will be cleared. A complex number expressed in rectangular coordinates with the y value equal to 0, or expressed in polar coordinates with the angle theta equal to 0, it's treated as a real number. Okay. Press math 0 to return the complex conjugate of the specified complex number. I forget what a complex conjugate is. Conjugate. I don't know. Alright. Let's jump over and do the calculations for 27. Okay. So those are here. And they're continued up here. So let's do this bit first. Alright. What have we got? So we go mode 3. What is 3? Complex. Okay. Okay. 12 minus 6i. Where is I? I. It's not jumping out at me. Just confirm. It's there's a button called I. Why can't I see it? No, I'm looking and I'm not seeing I. Okay, there it is there. Okay, if I press I, yeah, there you go. Alright, so when in complex mode, the fraction button becomes I. Now we know. 12 minus 6i plus 7 plus 15i minus, open bracket, 11 plus 4i, close bracket, equals x equals 8. And what's that? I equals 5. And if we scroll again, we're back to 8. So that's the real part is 8, and the imaginary part is 5. Very good. All right, let's do another one. So it's 6 times, open brackets, 7 minus 9i, close brackets, times, open brackets, 5 negative plus 8i close brackets, equals. So it's the real part is 222 and the imaginary part is 606. And then they've got another example, so let's do that. Okay, so we're going to go second function, RE. No, that's not what I wanted to do. Oh, it must be second function, RE. So, and then it's 8 angle 70 plus 12 angle 25 equals. We get a value for R. Oh, we've got the wrong value for R. Oh, why are we in XY mode still? Oh yeah, we're still in XY. Oh no, sorry, I've confused myself. Let's do it again. Second function, RE. Oh, there we go. Okay, put us in, yeah, I pressed ABC. Okay, sorry, my bad, I pressed the wrong button. 8 angle 70 plus 12 angle 25 equals 18.5 for R and 42.7 for theta. Cool. All right, now we're going to move up to the next bit, which is here, and we'll do those together. So, we go second function, xy, put us back in rectangular mode, and we go 1 plus I equals, and the real part is 1, and the, oh, I see. So we, second function, r theta, and then we're showing r is 1.4, and theta is 45. Cool. And the next one, second function, x to the y, to put us back in rectangular mode. And then we open brackets, 2 minus 3i, close brackets, squared, equals, the x value is -5, and the imaginary part is 12, or -12. Yeah. All right. And there's another example. So we've got open brackets, 1 plus I, oh no, not that, I, 1 plus I, close brackets. Let's do that again. Open brackets, 1 plus I, close brackets, second function, x to the -1 equals 0.5, and imaginary part -0.5. Very good. Okay, and then they've got the conjugate of 5 plus 2i. So math 0. Okay. Open brackets, 5 plus 2i, close brackets, equals, and you've got 5 for the real part and -2 for the imaginary part. Cool. So we're back over here. We've just finished complex number calculations. Now we're going to do matrix calculations. This function enables the saving of up to 4 matrices with 4 rows and 4 columns for calculations. Press mode 4 to enter the matrix mode. Matrix data must be entered prior to making calculations. Pressing up or down will display the matrix edit buffer along with up or down. Enter the value of each item, row, column, and then element, e.g. mat11, and press data after each. And after entering all items, press on/clear, then press math2 and specify mat A to D to save the data. Okay. To edit data saved in matrix A to D, press math1 and specify mat A to D to recall the data to the matrix edit buffer. After editing, press on/C, then press math2 and specify mat A to D to save the data. Before performing calculations, press on/C to choose the matrix edit buffer. When results of calculations are in the matrix format, the matrix edit buffer with those results will be displayed. At this time, you cannot return to the equation. To save the result in matrix A to D, press on/C, then press math2 and specify mat A to D. Since there is only one matrix edit buffer, the previous data will be overwritten by the new calculation. In addition to the 4 arithmetic functions, excluding divisions between matrices, x cubed, x squared, and x minus 1, the following commands are available. Okay. Dim, matrix name, row, column, returns a matrix with dimensions changed as specified. Okay. Fill, fill value row column, fills each element with a specified value. Qmol, matrix name, returns the cumulative matrix. Org, matrix name, appends the second matrix to the first matrix as new columns. The first and second matrices must have the same number of rows. Identity value returns the identity matrix with specified value of rows and columns. RND mat, row column, returns a random matrix with the specified values of rows and columns. Det matrix name returns the determinant of a square matrix. Trans matrix name returns the matrix with the columns transposed to rows and rows transposed to columns. And then you've got mat list, math 5, creates lists with elements from the left column of each matrix. Mat A, L1, mat B, L2, mat 3, mat C, L3, mat D, L4. Okay. Mode changes from matrix mode to list mode. Okay. And then you've got mat A list, which is math 6. Creates lists with elements from each column of the matrix. So matrix A goes to L1, L2, L3, L4. Mode changes from matrix mode to list mode. Alright, and they're going to give us some examples at number 28. Alright, so, oh dear me, I wasn't zoomed out, forgive me. So we've got 28 up here. Let's have a look at that. So we're going to have a 2 by 2 matrix A and matrix B. So we press mode 4 for matrix mode. And then we press down. Alright. 2 data, 2 data, 1 data, 2 data. And then I'm a bit confused. Anyway, let's keep going. We'll try 3 data, for data matrix 2 by 2. Okay, so then we press clear and we press math 2, which is store, and then 0, storing into matrix A. Okay, now let's press down and we press 2, data, 2 data. Okay, so that's first telling it the dimensions. Then 3 data, 1 data, 2 data, 6 data. Okay, and then we go on math 2 1. All right, so now we've got matrix A and matrix B specified. So let's press on C, math 0 0. So that's selecting matrix A and timesing it by math 0 1. Okay, and we press equals, and we've got rows 2. How do we scroll through these results? I'm not sure. Row 2 equals. I didn't want to do that. Can I press up to go back? I'm not sure. Let's try entering the expression again. So math 0 0 times math 0 1 equals. What about this? Oh, there we go. So it's 2 rows, 2 columns. 1 1 is 7, and oh no, that's not what I wanted. 1 1 1 is 7 and 13 and 17 and 27. Cool. All right, so we're going to take the inverse matrix. So how are we going to do that? We're going to have matrix A, math, no, what do we want? Yeah, math 0 0, math matrix 0, which is A, inverse second function, all right, equals. So it's a 2 by 2 matrix. It's minus 2, 1, 7, 1.5, yeah, 1.5, and minus 0.5. Cool. Okay, so let's say math 3 0, that's the dimension function, and we're going to import and then math 0 0s matrix A, second function, comma 3, second function, comma 3, close brackets, equals error 1. Oh, yep, I see. Let's try that again. So math 3 0, math 0 0, second function, comma 3, second function, comma 3, close brackets, equals. Am I getting something jumbled here? We're trying to call dimensions maybe it doesn't like it because it's giving a 3 by 3 output for a 2 by 2 input. I don't know. Let's try again. Math 3 0, math 0 0, second function, comma 3, second function, comma Oh, I see, of course. I've done this before. I'm using this comma over here. This is the one I need to use, this comma over here. Traps for young players. All right. So, math 3, 1, math 0, 0, second function, comma, 3, second function, comma, 3, close brackets, equals, error 1. Confounding. We must be making progress though. I must have pressed the wrong button again. What do we got? Math 3, 0, math 0, 0, second function, comma, 3, second function, comma, 3, close brackets, equals, and we've got a 3 by 3 matrix, and then we've got 1, 2, 0, 3, 4, 0, 0, 0, 0. Cool. Well, we got there in the end. Okay, now you can fill a matrix. Okay, so let's press math 3, 1, 5, comma, 3, comma, 3, close brackets, equals. Okay, and we've got a 3 by 3 matrix, and the numbers are 5, 5, 5, it's just all 5s. Cool. So we've got this CU mole. So math 3, 3. Oh no, 3, 2. I'm glad I got that right. 3, 2. And then math 0, 0 specifies matrix A. Equals. And we've got a 2 by 2 result. And it's 1, 2, 4, and 6. Okay. Oh, I see. So then we've got org. That looks like it's pretty complicated. So second math 3, 3, math 0, 0, second function, comma, math 0, 1, close bracket, equals. So we've got a 2 by 4 result, 1, 2, 3, 1, 3, 4, 2, 6. Very good. All right. So we're going to do an identity matrix. So we've got math 3, 4, 3 equals, and we've got a 3 by 3 result, 1, 0, 0, 0, 1, 0, 0, 0, 1. Very good. And then you can generate a random matrix. So let's do that. We get math 3, 5, 2, second function, comma, 3, close brackets, equals. So we've got a 2 by 3 matrix and then a bunch of random values in there. Cool. And we've got a determinant. So we can math 4, 0, math 4, 0, math 0, 0 equals -2. Great. And then we can translate map B. So math for 1, math 0, 1 equals, okay, it's a 2 by 2 and it's 3, 2, 1, 6. 3, 2, 1, 6. Okay, so that's just taken the B value and transposed it. And so we can create lists. I don't know where the lists are stored, but you press math and then you press 5. So yeah, mat list, math 5. Not sure what happens when you do that. Stores the list somewhere, I guess. Is 29 is separate. So we're going to go back over to the documentation and we're going to go through the list calculations. You can output these lists here. Create lists with elements from each column. Mode changes from matrix mode to list mode. So we must have just done that. I'm not sure what we did there. List calculations. This function enables the saving of up to 4 lists of 16 elements. I was going to take a break before we do lists. All right, well, we're nearly there. So up next is list calculations. This function enables the saving of up to 4 lists of 16 elements for calculations. Press mode 5 to enter list mode. Okay. Mode 5. List data must be entered prior to making calculations. Pressing up or down will display the list edit buffer along with up and down. Enter the value of each item, size, and then each element. For example, list 1. And press data after each. Okay, after, I didn't quite understand that, but maybe we'll understand it when we see the examples in a minute. After entering all items, press on/C, then enter math2 and specify L1 to L4 to save the data. Okay, so you make the list and then you allocate it to a variable. To edit data saved in L1 or N4, press math1 and then specify L1 to 4 to recall the data to the list edit buffer. After editing, press on, then press math2 and specify L1 to 4 to save the data. Before performing calculations, press on/C to close the list edit buffer. When results of calculations are in the list format, the list edit buffer with those results will be displayed. At this time, you cannot return to the equation. To save the results in L1 to 4, press on, then press math2 and specify L1 to 4. Since there is only one list edit buffer, the previous data will be overwritten by the new calculation. In addition to the 4 arithmetic functions, x cubed, x squared, and x to the minus 1, the following commands are available. Okay. So we've got sort A, which sorts list in ascending order, and sort D sorts in descending order. Dim list size returns a list with size changed as specified. Oh, okay. Fill value size, enter the specified value for all items. Okay. CU mul, I think it's cumulative multiply, sequentially cumulates each item in the list. Okay. DF list returns a new list using the difference between adjacent items in the list. Okay. Org list name returns a list appending the specified lists. Okay. Min list name returns the minimum value in the list. Max list name returns the maximum value in the list. Mean list name returns the mean value of items in the list. Med list name returns the median value for items in the list. Sum list returns the sum of items in the list. Prod list returns the multiplication of items in the list. Standard deviation returns the standard deviation of the list. Presumably that's the sample standard deviation. Var I returns the variance of the list. Oprod returns the outer product of two lists. iProd returns the inner product of two lists. In brackets of vectors, okay. Abs list returns the absolute value of the list. And then list to matrix, math 5, creates matrices with left column data from each list. L1, mat A, L2, mat B, L3, mat C, L4, mat D. Mode changes from list mode to matrix mode. And you can go to list mat A, creates a matrix with column data from each list, L1, L2, L3, L4 to matrix A. Mode changes from list mode to matrix mode. Alright, so let's have a look what they've got in store for us in the example list calculation. So it'll be 29, which is here. Let's see if I can zoom you in there. Alright, we're going to start on this section here, and then it goes over to the next page, so we'll have to have a look at that as well. Alright, so we're in mode 5, list mode, and then we press down, and then we press 3, data 2, data 7, data 4, data. Alright, and then we should press on, and then math 2, 0. So we're storing the list in L1, and then we press down, and we press 3, data, and then -3, data, -1, data, -4, data, on, math, 2, 2, 2, 1, 2, yeah, 1. List 2 is item 1. Okay. So if we're going to add L1 plus L2, then we just literally type that in. So we go math 0, 0 plus math 0, 1 equals a list of size 3, -1, 6, and 0. Cool. And we can sort L1, so that'll be math 3, 0, and then math 0, 0 equals list of size 3, 2, 4, 7. They're sorted, very good. We can sort them the other way, so we go math, and what is 3? 3 is OPE. Okay, and sort D is 1, and then we pass in list A, it's math 0, 0 equals, and we get a list of size 3, which is 7, 4, and 2, which are in descending order as we expected. So I'm not sure what this does. Dimension L1, 5. Oh, I see. It redimensions the list. So we've got a 3-dimensional list, I'm going to redimension it as 5-dimensional. So we go math 3, 2, and math 0, 0, second function, comma, 5, close bracket, equals. We got a list of size 5, 2, 7, 4, 0, 0. Very good. And we can fill 5, 5. So math 3, 3, 5, second function, comma, 5, close bracket, equals, list of size 5, and it's all 5s in there. Fair enough. So I don't think I'm going to do all of these because they're all the same. They're basically the same pattern. You choose the function by pressing by pressing math, and then choosing the category and then the specific thing that you want, and then you just give it the list out of the options 1 to 4, and then you get the results. So the only thing that we might do is the final one. So just to run you through, we do the CU mul, which is the cumulative multiplication, DF list, augment, then minimum, maximum, mean, median, sum, product, standard deviation, variance, outer product, inner product, absolute value, and this one, list matrix A. Oh, so you literally just press math 6, math 6, and it's put you over in matrix mode. Fair enough. All right. So let's call that done for lists. And now we've just got some information about error and calculation ranges. I think we're done. Oh, no. There's a table here. Maybe we'll look at that in a minute. So we're up to error and calculation ranges. Errors. An error will occur if an operation exceeds the calculation ranges, or if a mathematically illegal operation is attempted. When an error occurs, pressing left or right automatically moves the cursor back to the place in the equation where the error occurred. Edit the equation or press on/C to clear the equation. Error codes and error types. Syntax error. Error 1. An attempt was made to perform an invalid operation. For example, second function r theta. Okay. Calculation error. Error 2. The absolute value of an intermediate or final calculation result equals or exceeds 10 to the power of 100. An attempt was made to divide by 0, or an intermediate calculation resulted in 0. The calculation ranges were exceeded while performing calculations. Depth error, error 3. The available number of buffers was exceeded. There are 10 buffers. There's a note here, 5 buffers in other modes, and 1 buffer for matrix list data. So there are 10 buffers for numeric values and 24 buffers for calculation instructions in the normal mode. You will also get a depth error if the data items exceeded 100 in the statistics mode. Error 4 is equation too long. The equation exceeded its maximum input buffer of 142 characters. An equation must be shorter than 142 characters. Equation recall error, error 5. The stored equation contains a function not available in the mode used to recall the equation. For example, if a numerical value with numbers other than 0 and 1 is stored as a decimal, it cannot be recalled when the calculator is set to binary. Okay. Memory over error, error 6. Equation exceeded the formula memory buffer, 256 characters in total in F1 to F4. Invalid error, error 7. Matrix/list definition error, or entering an invalid value. Dimension error, error 8. Matrix/list dimensions inconsistent while calculating. Error 9 is invalid dim error. So the size of the matrix or list exceeds calculation range. And error 10 is no define error. Okay. Undefined matrix list used in calculation. Okay. It's not really idiomatic English, is it? No define error. What they mean is that undefined matrix list using. That's okay. All right, now we've got calculation ranges, and here's where the 30 is. Let's have a quick look at this, and then we'll see what they've got on the other sheet. Within the ranges specified, this calculator is accurate to plus or minus 1 of the least significant digit of the mantissa. However, a calculation error increases in continuous calculations due to accumulation of each calculation error. This is the same for y to the x, xth root, n factorial, e to the x, ln, matrix list calculations, etc., where continuous calculations are performed internally. Additionally, a calculation error will accumulate and become larger in the vicinity of inflection points and singular points of functions. Calculation ranges: plus or minus 10 to the power of negative 99 through to plus or minus 9.999999999 times 10 to the power of 99 and 0. If the absolute value of an entry or a final or intermediate result of a calculation is less than 10 to the power of negative 99, the value is considered to be 0 in calculations and in the display. Oh, that's interesting. So they've got some stuff over here. What's this? Okay, this is oh, okay. So yeah, this is the function and the dynamic range. Okay. There you go. So I don't think we're going to geek out over these statistics. Oh, we might as well have a quick look. So for sine, cos, and tan, absolute value of x must be less than 10 to the power of 10. For tan, x the absolute value of x can't equal 90 times 2n to the minus 1. Okay. Yeah, I'm not going to go through all of these, but the limits are specified. You see a lot of 10 to the 100s, like it said in the thing. So there you go. Actually, we might as well go through them. Why not? So as we said, sine, cos, and tan, they've got some limits there. Inverse sine, inverse cos, the absolute value of x must be less than or equal to 1. Inverse tan, or the cube root of x, the absolute value of x must be less than 10 to the power of 100. Ln x log x, x has to be between 10 to the negative 99 and 10 to the 100. Y to the x, y greater than 0, then x log y I'm a bit confused by the notation they're using there. Oh, I see. So for y is greater than 0, x has to be in the range minus 10 to the 100 less than x log y less than 100. Y equals 0, you've got x can be anything between 0 and 10 to the 100. Y is less than 0. Oh, that's all a bit confusing, isn't it? Anyway, they've got the x root of y. They've got e to the x. X can be anything up to 230 odd. It's quite strange, isn't it? I guess because at that point it overflows the 10 to the 100. 10 to the x, x can be anything up to 100. Okay. Sinh, cosh, I don't know how you pronounce tan h. Again, there's that 230. Must be some sort of exponential. For inverse sine h, it's 10 to the 50. Same for cos h inverse. Okay, tan h inverse has to be less than 1. X squared can be anything less than 10 to the 50. X cubed, anything less than 10 to the 33. Square root of x for anything up to 10 to the 100. Inverse of x can be anything less than 10 to the 100 or not 0. N factorial up to 69. Oh, I see there's asterisks here to indicate that it has to be an integer. So then you've got ampere, NCR, degrees. Okay, you can have 0.00001. So that's 5 decimal points for the seconds in a degrees. And you can have up to 10,000 hours. And you've got, okay, the square root of x squared plus y squared has to be less than 10 to the 100. So the r in r theta can be anything up to 10 to the 100. Theta has to be less than 10 to the 10 degrees. It can convert degrees and radians up to 10 to the 100, but gradients is only 10 to the 98. And then the rules for the bits and pieces in a complex number are 10 to the 100, and that pretty much does that. And then decimal, binary, pental, hexadecimal. Okay. So those look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So they support a fairly large number for different bases. It's not 32 bits, it's more than that. Look at that, the maximum hex value is FDAB F4 1C01. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so instead of 8 digits, it's 10 digits. And then there's specs for not and negative, and that's it. So there's some notes there about EU stuff. There's a sharp.net.au. I'll check that out. I'll put that in the show notes. And then there's some information about battery disposal, and here's the physical constants and the metric conversions, which we saw earlier. So that does that for calculation ranges. Then there's some information about battery replacement, which we already did, didn't we? Because we had a flat battery. So we saw how to do that earlier. The automatic power off function. This calculator will turn itself off to save battery power if no key is pressed for approximately 10 minutes. I think there's an option there you can turn it to 60 minutes, or maybe I'm getting my wires crossed with some other calculator. Anyway, and there's a few specs here, so I might as well rattle them off. Calculations. Scientific calculations, complex number combination calculations, equation solvers, statistical calculations, etc. Internal calculation, mantissa of up to 14 digits, pending operations, 24 calculations, 10 numeric values in the normal mode, 5 numeric values in other modes, and 1 numeric value for matrix and list data. Power source is built-in solar cells and a 1.5 volt DC backup battery, alkaline battery LR44 or equivalent. Operating time approximately 5,000 when used continuously. Varies according to use and other factors. 55555 at 25 degrees Celsius, 77 Fahrenheit, using the alkaline battery only. Okay. Operating temperature 0 to 40 degrees Celsius. External dimensions 80 millimeters by 161 millimeters by 15 millimeters. And then there's the sizes in inches. The weight is approximately 110 grams, including the battery. The accessory is the battery. There's an operational manual and a hard case. For more information about Scientific Calculator, visit our website, sharpworld.com/calculator. And here is the case that it was referring to. So there's some notes here on the back. I'll show you those. So setup menu, so you can set the degrees to degrees, radians, or gradients. The FSE is the answer display format. I'm not sure what it stands for. Anyways, 0 for fixed, scientific for scientific, engineering for engineering. There's normal 1 and there's normal 2. And the tab is the number of decimal places. And the mode selections, as we've run through: normal mode, statistic mode, equation mode, complex number mode, matrix mode, and list mode. And this is the EL-506TS. And I'm not sure what the AO59 is, not sure. And it just slots in there, happily. And then when we're done with it, we can pop it out and pop it back in. There. Wonderful. So, I'm going to take you over to the farewell cam. We'll wrap up.
And that's a wrap. So that took a little while to get through, didn't it? Actually, I'll tell you what, before we wrap up, let's jump over to the computer together. We'll just have a quick look at what's on the web. We've come this far, we might as well just have a little bit more. Let's have a look.
Okay, I thought just before we wrap up here that I'd show you the information that's available on the website. This is my page for the EL-506TS that we've just been looking at over on my wiki. That's jj5.net/wiki, and this is sharp EL-506TS. It's one of many calculators I have. We won't look at the others just now. My specific model obviously is the EL-506TS BWH. The B stands for bubble wrap, I think, or blister pack or something, and then WH stands for white, which is because mine is colored white, which is the model they sell in Australia. In the TSBBW is sold in America, and it's black with white accents. I haven't seen one of those, but I think I saw a photo and it's just basically black instead of white. I got the Sharp EL-506TS model out of nostalgia for my Sharp EL-546L, which is a scientific calculator I grew up with. The EL-506TS is the latest in the EL-500 line. I purchased mine from here, and I'll show you that in just a second. The specifications from the global site are here. There's some additional information here, and the manual is here. So, okay, looks like Firefox doesn't want to play. Let's try that again. So where were we? John's wiki. All right, and somewhere in here I'll have my calculators. Calculators. There we go. All right, and we were looking at the Sharp EL-501. As I mentioned, I do have some other calculators: 2 Sharps, 2 Casios, Texas Instruments, and a HP Prime G2 graphing calculator. So what we were looking at, where I got it, the global specs, the Aussie specs, and the manual. So yeah, I bought it on eBay. Looks like oh no, it's out of stock. I bought them out of stock, so we're sold out over here. Yeah, this is the eBay page. Not much to tell you. Looks like it's okay. So it gives you a bunch of the specifications here. Very good. We'll probably see the same everywhere. These are the specs on the global site, which is a bit terrible, isn't it? Look at that. It looks like it's from like 1998. So that's not a very good web page, is it? It's a bit embarrassing, actually. Anyway, we won't go through all the details there. They're not very well specified. This is obviously where they got their. So this is the eBay listing, and this is the thing. So they've obviously copied that out there. Very good. And this is the manual. It's 44 pages. Might as well scroll through the contents. So read before using, key layout, reset switch, display pattern, display format and decimal setting function, exponent display, angular unit, okay, functions and key operations, on off, entry correction keys, data entry keys, random key, modify key, basic arithmetic keys, parentheses, percent, inverse square cube, x to the power of y, square root, cube root, x root, y to the power of x, common logarithm, e to the power of x, natural logarithm, factorials, permutations, combinations, time calculation, fractional calculations, memory calculations, last answer memory, formula memories, trigonometric functions, arc trigonometric functions, hyperbolic functions, coordinate conversion, binary, pental, octal, decimal, and hexadecimal operations, n-base, differentiation calculation, integration calculation, simulation calculation, statistics functions, data input for one variable statistics, answer key for one variable statistics, data correction, data input for two variable statistics, answer key for two variable statistics, simultaneous equations, complex equations, matrix calculation. Okay, so how to operate, read before using. This operation guide has been written based on the EL-506TS model. Very good. We've got second function and alpha keys. Pressing these keys will enable the functions written in orange or green. Orange for second function, alpha for green. Above the calculator buttons. On off, on C, off keys, power on. /C is for clear, it clears the current value. Second function off, power off, written in orange above the on/C key. Home key. Pressing this key will return to normal mode. Okay, cool. Math, various functions. Okay. Mode key. So this calculator can operate in 6 different modes as follows. Normal mode is mode 0. Normal mode for performing normal arithmetic and function calculations. Stat mode. Stat mode equals mode 1 is stat mode. Mode for performing one or two variable statistic calculations. To select the submode, press the corresponding number after mode 1. So you've got single variable statistic calculation, linear regression, quadratic regression, exponential regression, logarithmic regression, power regression, inverse regression. We've got equation mode, mode 2. Mode for equation solvers. To select the submode, press the corresponding number key after mode 2. So there's linear equation with 2 unknowns, linear equation with 3 unknowns, quadratic equation, and cubic equation. Then there's complex mode is mode 3 for complex number calculation, mode 4 for matrix calculations, and mode 5 for list calculations. There's a reset switch to recalibrate everything. You can press the reset pin, or you can press something. If the calculator fails to operate normally, press the reset switch on the front to reinitialize the unit. The display format and calculation mode will return to their initial settings. No, pressing the reset switch will erase any data stored in memory. Okay, there is another way to do the same thing through the interface, I think, but you can just press the reset pin. Okay, and we've got some documentation about the display pattern. So hyperbolic symbol. Where are we going to start? Let's start here. Complex calculation mode, so it's in rectangular or polar. Second function, whether that's active or not. Hyperbolic flag. Alphabet symbol. So okay, it's like the second function menu, but for variables. Display format will be either fixed, scientific, or engineering, or normal. There are two normal modes. I don't know how you know which one you're in. Maybe you just have to infer it. Angular unit indicator, so it's either degrees or radians or gradients. Mode symbol, so looks like matrix list statistics mode can be displayed. Memory symbol, M. I'm not sure I don't know what that means. If that means there's some values in memory, I don't know which memory it refers to. Okay, there's an arrow which appears when the entire equation cannot be displayed. There's an equation display line, which is the top line here. There's an exponent display, which is here. There's an imaginary number symbol for complex calculations. The numeric display line, which is the mantissa plus the exponent. And there's an argument symbol for complex calculations. So that's the angle there. I'm not sure what the plus and the question mark mean. Appears when there is a previous or next item. That's the up or down arrow keys. And then there's something which appears when the entire equation can't be displayed. Okay, so it's left and right and up and down. Very good. The actual display does not appear like this. This illustration is for explanatory purposes only. Yeah, of course. Because not all the things show at the same time. Display format and decimal setting function. Okay, so there's fixed and so on. You can choose the angular unit. Very good. So you can turn the thing on and off. Data entry. Random keys. So you can generate random numbers. MDF. I don't know what MDF stands for. It'd be good if I could figure that out. Function to round calculation results. Even after setting the number of decimal places on the display, the calculator performs calculations using a larger number of decimal places than that which appears on the display. By using this function, internal calculations will be performed using only the displayed value. So you just press MDF and it puts the rounded value into the result. I really don't know what MDF stands for. Let me see if I can figure it out. I'll be back in a second. All right, so what I found out is no one really knows. People have speculated that MDF stands for MDF, which are letters in the word modify. So it just calls it the modify key, labels it MDF, and doesn't tell you what MDF stands for. But it is called the modify key, so there you go, it's the modify key. This is frequently used in scientific and technical fields as well as business when performing chained calculations. Yeah, right. Basic arithmetic keys and parentheses. Okay. Percent tells you how to use percent. There's a bunch of square, inverse square, all that good stuff. We've got 10 to the x and log x. We've got e to the x and ln x. We've got factorials. Did we have gamma, by the way? I thought we saw gamma in the manual. Did we remember seeing gamma? I don't know. Permutations, combinations. I'm going to duck over and just see if I can find out about gamma. Yeah, so the sharp calculator that we're looking at doesn't have gamma function. It does have n factorial. The reason I got my wires crossed is I'm reading this book here, which is How to Use a Scientific Calculator. And in it, I'm up to the section on gamma calculations. I'm not sure if you can see that. Anyway, that's why I had it on the brain, because I did see that recently. Gamma is, I think, like factorial, but it's for values other than integers, or as well as integers, I think. I'm not an expert. Anyway, it's not relevant to what we're doing here. So there's n factorial, there's NPR and NCR, time calculation with hours, minutes, seconds, fractional calculations, mixed fractions and improper fractions, memory calculations with the memory variable m, and there's values a to f, x and y and m, so there's a bunch of them. Also answer memory, last answer memory, formula memory, so you can stash formulas in 4 different formula memories, trig function, sine, cos, tan, and then of course all of the other ones that are based on it. You can change the degrees measurement or units. Then there's the arc trigonometric functions, hyperbolic functions, and I suppose the arc hyperbolic functions. Coordinate conversion, rectangular and polar. There's a function for splitting data for dual variable input. Very good. And then this comma arrow thing scrolls through values, so you can show the real part or the angle or the x and y value. Then we talked about all of the n-base support, differentiation calculations, okay, integration calculation, simulation calculations, statistics functions, various modes, various measures, data correction so you can edit stuff, data input for variable statistics. Very good. So it looks like they've got an example here. Data table. Answer keys for variables, 2 variable statistics. So there's extra values for 2 variables. Simultaneous calculation, complex calculation, matrix calculation. And then we've got a sharp title page there at the end. Okay, that's the whole thing. So we had a quick squiz through the manual. We found the specifications on the website. This is the Australian website. Looks much prettier than the global website, which looks kind of terrible. I suppose it's a bit late now to be going through. We might as well just have a quick read of this and then we'll wrap up. So everything that we've been looking at today is the EL-506TS. This is a scientific calculator with 470 advanced functions. This is white one. Mine is white. That's what you're dealing with. The EL-506TS-BWH performs over 470 advanced scientific functions and utilizes a 2-line display and multi-line playback to make scientific equations easier for students to solve. It is ideal for students studying general math, algebra, geometry, trigonometry, and calculus. In addition, it can be used for statistics, biology, chemistry, and physics. Flexible, advanced, and despite its 470 functions, still easy to use, the scientific calculator covers all the needs of daily school and university demands. And then we've got where to buy. Very good. Features: scientific calculator, LCD display, twin-powered fraction calculation. So, a scientific calculator designed to calculate problems in science, engineering, and mathematics. Great for school or engineers. 2-line display showing equation entered on top line and answer on the bottom line, allowing users to check both the equation and answer at the same time. User can amend the equation if needed. Solar powered with one LR44 battery as backup. Calculator can be used both during the day and night. Battery is secured with child-safe lock. Operating time is approximately 5,000 hours. Use the alkaline battery only. Auto power off after approximately 10 minutes. 9 values can be stored in the calculator with 8 temporary memories and 1 independent memory. Can perform 470 advanced scientific functions. Converting decimal to scientific or engineering notation allows you to enter numbers and equations as fractions. In addition to the 4 basic arithmetic functions, excluding division between matrices, x3, x2, and x minus 1. I think that's supposed to be x cubed, x squared, and inverse x. Users are provided with transpose and cumulative matrix functions. Okay. Calculating complex numbers in the form of a plus bi. When a series of bivariate data has been entered correctly, then the calculator can be used to find the values of a and b to give the equation of the line of regression from which we can make estimates of the variable y of the equation y equals ax plus a plus bx. Send sales or support inquiry, click here, or call our friendly team. And that's an Australian number there they've got. Very good. So let's have a look at the specifications. All right, we've got general information. So this is a scientific calculator with a 2-line LCD display, dual power, solar and battery, memory, 9 memories. Scientific calculators, 470 functions, a fraction key. Yes, there we go. It's pretty boring, isn't it? Warranty for 12 months. Okay, and downloads, what have we got? The operation manual. So we've already seen that. That's what we had a look at earlier here, I think. Yeah. All right. Well, now it is a wrap. So I'll take you over to the farewell camel wrap up.
Okay, that really is a wrap. So we've gone through the whole user manual for this particular Sharp calculator. We got through the front and the back. It's all scanned. It's on the web if you want to get access. There'll be a link in the show notes. We went through all of the calculation examples. That was 2 whole pages as well. So we've had a pretty good look at this calculator, and we have a pretty good idea about the extent of its functionality. So that's pretty cool. Of the scientific calculators that I have, this is probably the least sophisticated one, apart from the one that it replaces, which is the old one from 1993, which is this old thing. But I do have a soft spot for this line of calculators from Sharp. So I might still find myself reaching for it when I'm just doing a simple calculation that I could do on any old calculator. I think that the segmented display is kind of cool. Like, if you're doing complex stuff, you probably want to have a multi-line display like you have with the Casio FX line of calculators, the 991CW and the 991CX, which is, sorry, CW and EX. We'll be looking at those on the channel again in the near future. So the Casio display is certainly more capable than the Sharp display, but there's something sort of homey about the 7-segment displays, and you really only need one line to show a number. Of course, if you're showing a fraction or a square root symbol or something like that, you're going to appreciate having the extra screen real estate, but there's not really much call to do that, and often you're just dealing with numbers anyway, so you don't need all of those fancy formatting options. So yeah, happy to have that segmented display, and perhaps it's a little bit more practical. I actually noticed while we were doing the demos here that in complex mode, the negative sign for the value turned up all the way over on the left-hand side rather than immediately next to the value. I'm not sure if you noticed that when we were going through, but yeah, I think I saw that it's not consistent, the Sharp calculator on where the negative sign is, depending on whether you're in complex mode or anyway, I didn't have a close look at that, but I think I did notice something along those lines. Anyway, I think I'm rambling. I'm rambling because I'm tired, because I've been spending hours going through this Sharp calculator. But I think we made it through to the end, and now we know pretty much everything there is to know. So that's the end of this video. I hope you enjoyed this video. Thanks very much for watching, and please remember to click like and subscribe.